Hello, and welcome to Space for Sleep. I'm so glad you're here tonight. Maybe you're curled beneath a soft blanket, lights dim, the day slowly fading behind your eyelids. Maybe you're lying awake, just letting your thoughts wander into the quiet unknown. Wherever you are, this space, this moment, is yours. A place where science slows down, where curiosity feels calm again. Before we begin, if you enjoy drifting through these quiet explorations, if you love learning about the universe at a pace that lets your mind breathe, I'd be deeply grateful if you left a gentle like, subscribed, or even joined as a member. It helps me keep these stories ad-free, unhurried, and full of wonder. Now, take a slow breath, and let's begin. Tonight, we're not leaving home. We're learning what home truly means. When you step outside and look up into a clear night sky, what you see is not just stars, it's history, it's time, it's distance so great that even light, traveling at 186,000 miles per second, becomes ancient before it reaches your eyes. Somewhere in that soft band of light, stretching across the darkness, that faint, milky glow that our ancestors once mistook for spilled milk from the gods, lies everything we've ever known. Every star you've ever wished upon, every constellation, every sunrise, every story. All of it exists inside one grand structure, the Milky Way galaxy. For most of human history, no one knew what that silvery river in the sky really was. To the Greeks, it was the milk of Hera. To the Mayans, the path of souls. To countless cultures, it was the scar of creation itself, the mark of the divine. But even then, something deep in us must have felt it, that this glowing band wasn't just decoration, it was something bigger, a clue to where we belong. We call it our galaxy, from the Greek galaxies, meaning milky circle, but that name barely begins to hold what it really is. The Milky Way isn't a circle, it's a vast, rotating system of hundreds of billions of stars, a spiral of light and gravity turning slowly in the dark. Our sun is one of those stars. Just one. Orbiting quietly on the inner edge of a minor spiral arm called the Orion Arm, about 27,000 light-years from the galactic center. That means that when you look toward the constellation Sagittarius, you're gazing straight toward the heart of our galaxy, toward the crowded, golden core where stars are packed so densely that their light blends together in a glowing haze. And yet, even from that distance, even from the quiet outskirts where our solar system drifts, we are still part of it. Every atom in our bodies, every molecule in your breath right now, was once inside a star of the Milky Way, born in its furnaces, scattered by its explosions, and gathered again into new forms, like you and me. So, how big is it, this home of ours? Let's start with what we can see. The bright disk of the Milky Way spans about 100,000 light-years from edge to edge. That's roughly 600 trillion miles, a number so large it loses all meaning. If you could travel at the speed of light, faster than anything we know, it would still take you 100,000 years to cross from one side to the other. In human terms, that's longer than the entire history of civilization. Every step of human culture, from cave paintings to cities to space travel, would fit inside the tiniest fraction of a single galactic orbit. And speaking of orbits, our sun takes about 230 million years to circle the center of the galaxy once. That's one galactic year. So far, the sun has completed just over 20 of them. The last time it was in this position, dinosaurs roamed the Earth, the continents were still shifting, and the night sky looked entirely different. Yet despite its size, the Milky Way is incredibly thin, a cosmic disk only about 1,000 light-years tall, floating like a silver coin in the dark. Within that disk lies everything we know: stars, nebulae, star clusters, clouds of gas, and the strange invisible glue that holds it all together: dark matter. From where we stand, we can't see the whole galaxy. We're inside it, surrounded by its stars. Imagine being in the middle of a vast forest, trying to see the shape of every tree. You can't step outside it. You can only infer its form from the way the light filters through the branches. That's how astronomers study the Milky Way, by mapping stars, tracing gas clouds, and measuring motions to build a picture of the structure we live inside. When telescopes first revealed that the Milky Way was made of individual stars, humanity's view of the universe changed forever. Suddenly, we weren't at the center of creation. We were residents of a galaxy, one among many. Later, we learned that the Milky Way itself was just one of trillions of galaxies scattered across the expanding universe like grains of cosmic dust. But even so, the Milky Way remains personal. It's our neighborhood, our cosmic hometown. Inside its spiral arms, stars are born and die in an endless cycle. Vast clouds of hydrogen collapse under their own weight to form new suns. Planets take shape around them. And somewhere, maybe not far from here, life might rise, wonder, and look back at the same galactic glow we do. If you could somehow step outside the Milky Way and look back, you'd see a magnificent spiral, a glowing disk with graceful arms curling outward, each sparkling with millions of stars. You'd see dark lanes of dust cutting through the light, and pink patches of nebulae where new stars ignite. At the center, a bright bulge glows, the heart of the galaxy, where stars swarm around a massive, invisible object, the supermassive black hole called Sagittarius RO. And far beyond the visible light, you'd see a vast halo of stars, clusters, and dark matter, extending hundreds of thousands of light-years farther than the eye can see. That's part of the answer to our question. Because the Milky Way's true size isn't limited to its visible stars. Its gravitational influence, its hidden mass, stretches much, much farther. Scientists estimate that if you include the dark matter halo, our galaxy could span 1 million light-years from edge to edge. That's 10 times larger than what we can see in light. It's like discovering that your home extends far beyond its walls, invisible, but still real, still part of what holds everything together. So when we ask, how big is the Milky Way? We're not just talking about distance, we're talking about depth, about complexity, about the idea that even something as vast as a galaxy can't be fully seen all at once, that we can live inside something for our entire existence and still be learning what it truly is. In a way, that's what makes this question beautiful. Because the Milky Way isn't just an object in space, it's a relationship between matter and gravity, between light and darkness, between the human mind and the universe it's trying to understand. Tonight, as you listen to this, remember that you are moving, right now, through that vast spiral. You, your room, your city, your planet, all of it is orbiting the galactic center at nearly 500,000 miles per hour. Yet you feel nothing. You're gliding silently through a sea of stars, carried by an invisible current of gravity older than life itself. So breathe, and let that thought settle. The Milky Way isn't just where you are, it's what you are. You are part of its atoms, its story, its long, slow turn through time. Every heartbeat, every breath, every dream, all of it happening within a single star system, inside a single arm of a single galaxy that's 100,000 light-years wide. That's home. And in the next part of our journey, we'll trace that soft river of light back through myth, memory, and science to discover how humanity first began to understand the galaxy we live inside. Until then, thank you for spending this quiet time among the stars. If you'd like to keep exploring the universe with me, please leave a like, subscribe, or even join as a member to help me continue creating these peaceful cosmic journeys. Sleep gently, and let your thoughts drift across the spiral arms of the galaxy that made you, our Milky Way. For as long as people have looked up at the night sky, they've seen the same river of light, a pale, misty band stretching across the heavens, faint but unmistakable, curving gently from one horizon to the other. In the stillness of ancient nights, without city lights or airplanes or satellites, it must have looked impossibly vivid, a glowing scar laid across the darkness. the Milky Way, a name so old it predates astronomy itself. To the ancient Greeks it was the milk of Hera, spilled across the heavens as she fed the infant Heracles. To the Chinese it was the Silver River, a bridge between the weaver girl and the cowherd, lovers separated by the gods. To the Maya it was a path of souls, guiding the dead through the underworld. Every civilization gave it a story, because everyone saw it, a shared vision in every sky. Long before telescopes, before science, before even written language, humans stood beneath that shining arc and wondered what it was. They knew it was something vast, something unreachable, something eternal. But no one could imagine its true nature. To them, the stars were fixed lights on a celestial dome, perhaps tiny holes letting through the fire of creation. The Milky Way was thought to be something separate, a heavenly substance, a cloud, a spirit, or a river made of light itself. And in a way, they weren't wrong. It is a river of light, not flowing water, but billions of stars so far away that their light blurs together into a single luminous current. But it would take thousands of years before anyone could even begin to understand that. The first person to suspect the truth was a philosopher from ancient Greece, Democritus, around 400 BCE. He suggested that the Milky Way might be made up of distant stars, their light blending together in the distance. It was a guess, pure imagination, centuries ahead of its time. Most people dismissed it. The heavens, they believed, were perfect and unchanging. The idea of countless hidden stars scattered beyond sight was simply too vast to comprehend. Then, in the 17th century, a revolution began. Galileo Galilei turned his small telescope toward that hazy band, and what he saw changed everything. Through the lens, the Milky Way dissolved into thousands of individual points, each one a star. Galileo realized that what appeared as a cloud to the naked eye was, in fact, an ocean of suns. He wrote, "The galaxy is nothing else but a mass of innumerable stars planted together in clusters. For the first time, the illusion was broken. The river of light was revealed as a sea of worlds, but knowing that the Milky Way was made of stars was only the beginning. How big was it? What shape did it have? And where were we inside it? Those questions would take centuries to answer. In the 18th century, William Herschel, one of astronomy's great dreamers, decided to map the galaxy. Using his powerful telescope, he counted stars in different directions, reasoning that more stars meant a thicker part of the galaxy. After years of patient observation, he drew what he believed to be the first map of the Milky Way. A flattened disk of stars, roughly circular, with the sun sitting near the center. It was beautiful, it was wrong, but it was a beginning. Herschel's work planted a seed, the idea that the Milky Way wasn't just a patch of sky, but a structure, something vast and coherent. And over the next century, that idea grew. By the early 1900s, astronomers like Jacobus Kapteyn began building more sophisticated star maps, measuring brightness, color, and motion. They started to see hints of the true scale, but still thought our sun was near the middle. It would take one extraordinary discovery to reveal how far off that picture really was. That discovery came from a man named Harlow Shapley. In 1918, he studied globular clusters, dense, spherical groups of old stars that orbit the galaxy. He realized these clusters weren't scattered randomly. They formed a kind of halo, centered on a point far from the sun. That point, he concluded, was the center of the Milky Way. It was a stunning revelation. For the first time, humanity knew where we were, not in the center, but in the suburbs. The Milky Way wasn't built around us. We were simply one part of a much larger whole. Imagine how that must have felt, to discover that everything you'd ever known, every sunrise and star and story, was not the center of anything. It was humbling, but also beautiful. Because it meant the galaxy was even larger, even grander, even more mysterious than anyone had imagined. As telescopes grew stronger, so did our understanding. The Milky Way wasn't just a flat disk. It had spiral arms, regions of star birth, lanes of dust, and a dense, radiant core. In the 1950s, radio astronomers mapped the spiral structure for the first time using the 21-centimeter hydrogen line, invisible to our eyes but clear to their instruments. What they found was breathtaking, a spiral galaxy, graceful and vast, stretching across 100,000 light-years. And yet, even that is only what we can see. The visible stars are just the luminous skin of something much larger, wrapped in halos of dark matter that we can't directly detect. The Milky Way is surrounded by this invisible mass, a ghostly sphere extending hundreds of thousands of light-years beyond the shining disk. That unseen structure is part of the galaxy too, and it may hold most of its mass. So, the Milky Way, in truth, is far bigger than our eyes, or even our telescopes, can fully reveal. But long before we could measure it, long before we had words like light year or dark matter, humans already felt its vastness. The Milky Way has always been more than an object. It's a symbol of mystery, of home, of connection. It has guided travelers, storytellers, and dreamers for millennia. In the deserts of Africa, it marked the path to water. In the Pacific, Polynesian navigators used it as a compass across open seas. In the Arctic, Inuit legends said it was the trail of spirits moving across the sky. All of these stories, from every culture, point to something the ancients understood in their own way, that the Milky Way binds us together. It reminds us that we share one sky, one home, one story written in light. When you stand beneath that band of stars, you're seeing something ancient and alive. The light that reaches your eyes left its stars tens of thousands of years ago, long before the first cities rose. Some of that light began its journey when glaciers still covered half the earth. And yet, here it is, crossing time and space to whisper, "You belong to something enormous." It's strange to think about how much we take it for granted now. In cities drowned in light pollution, the Milky Way is often invisible. Most people will never truly see it, never feel what it's like to stand under that glowing arc in complete darkness, to sense the weight of the galaxy above you. But for those who do, it's unforgettable. It feels like looking into the heart of everything. So tonight, even if you can't see it, imagine it. Picture the Milky Way as it once appeared, a soft river of silver light arching across a silent sky. Billions of suns flowing together in a cosmic current, each one burning through its own story, its own time. That's what we live inside, a river of stars so vast that even its light can lull us into wonder. In the next part of this journey, we'll follow that river deeper, to learn how astronomers began to measure its shape, its structure, and its staggering scale, how they turned curiosity into numbers and myth into map. But for now, just rest with the image. A ribbon of light, curving gently across the heavens, ancient, endless, and home. Thank you for drifting through this quiet part of the cosmos with me. If you're enjoying this slow journey, please leave a like, subscribe, or become a member to keep these explorations peaceful and ad-free. Until next time, sleep softly and let the river of stars guide your dreams. When we try to imagine the size of the Milky Way, the numbers start to slip through our fingers. They're too large, too distant, too abstract. Our minds were built for rivers and mountains and skies, not galaxies. But that hasn't stopped us from trying to measure them. From the moment we realized that the Milky Way wasn't just a streak of light, but a system of stars, we began to wonder, how far does it go? How big is home? It's strange to think about how something we can see so clearly in the sky could be so difficult to measure. You'd think, after thousands of years of looking, we'd have an answer. But measuring the galaxy from inside it is like trying to guess the shape of the forest while standing among the trees. You can't step outside and look back. You can only use what you can see and what you can reason. And for centuries, that was all we had. Reason, patience, and the faint shimmer of light. In the late 18th century, William Herschel took the first great step toward measuring the Milky Way. Night after night, he counted stars. He used a telescope of his own making and measured how many stars appeared in each direction. His logic was simple. If the galaxy were thicker in one direction, there would be more stars that way. If thinner, fewer. After years of work, he produced a rough map, an uneven, flattened disk of stars with the sun placed near the center. Herschel believed he had charted the boundaries of the galaxy itself. It was a magnificent idea, but it wasn't quite right. The stars he saw were only those bright enough for his telescope to detect, and interstellar dust blocked the light of those farther away. What he had actually mapped was a small portion of the galaxy, a glowing pocket within a much larger whole. Still, Herschel's work was revolutionary. It showed that the Milky Way had structure, that it was not a random scattering of stars, but something organized, something shaped. For the first time, the idea of the galaxy as a physical system took form. More than a century later, the next breakthrough came from Harlow Shapley, a quiet astronomer with a talent for thinking big. Instead of counting stars, he looked to globular clusters, dense, spherical swarms of ancient stars that orbit the Milky Way like bees around a hive. He noticed that these clusters weren't evenly distributed across the sky. They seemed to cluster toward one particular region, the constellation Sagittarius. That, he realized, must be the true center of the galaxy. Using the brightness of variable stars within those clusters, Shapley was able to estimate their distances, and by extension, the scale of the galaxy itself. His calculations were astonishing. The Milky Way, he concluded, was over 100,000 light-years across, far larger than anyone had imagined, and the Sun was not near the center at all, but far from it, on the outskirts of a great spiral. It's hard to appreciate what a shock that was. For centuries, humanity had placed itself in the middle of everything, the center of creation, the center of the solar system, the center of the galaxy. But Shapley's work shattered that illusion. Once again, we were off to the side, orbiting quietly in the suburbs of the cosmos. And yet, instead of making us smaller, that discovery made the universe more beautiful. It gave it depth. Still, there was something else hidden in Shapley's data, something even he didn't realize. The distances he measured were vast, but his calibration was off. His numbers were too large by about a factor of 2. The galaxy was still enormous, just not quite that enormous. It would take time and new methods to refine the picture. In the early 20th century, astronomers began to develop new ways to measure distances using a kind of star called a Cepheid variable, a star that pulses in brightness at regular intervals. Henrietta Leavitt discovered that the period of these pulses was linked to the star's true luminosity. The longer the period, the brighter the star. By comparing the apparent brightness we see from Earth to the true brightness inferred from the period, astronomers could calculate how far away the star was. This became one of the most powerful tools in cosmic measurement, a kind of celestial yardstick. With Cepheid variables, distances that had once been guesses became measurable. Stars could now be placed at precise points in space. And with those distances came maps, better, deeper, more accurate maps of the Milky Way. But even with these new tools, one problem remained: dust. The same cosmic dust that paints the Milky Way's dark lanes also hides much of its light. Ordinary telescopes, which see only visible light, can't pierce those clouds. That's why, even today, we can't see the galactic center directly. But light comes in many forms, and not all are blocked by dust. In the 1950s, astronomers turned to radio waves, specifically the 21-centimeter emission line of neutral hydrogen. Hydrogen is the most abundant element in the galaxy, and when its atoms flip their magnetic orientation, they emit a faint radio signal. That signal can pass through the dust that blocks visible light. By mapping these radio waves, astronomers could trace the spiral arms of the Milky Way from within. What they found confirmed the galaxy's shape at last, a barred spiral, with sweeping arms curving out from a bright, central bulge. The Milky Way wasn't just a flat disk of stars, it was a dynamic, rotating system with gas and dust and dark matter all woven together in a cosmic whirlpool. And still, even that wasn't the end of the story. The more we measured, the more we realized that the galaxy's true boundary wasn't clear-cut. The farther out we looked, the fainter and more diffuse the stars became, until they blended into a halo of ancient clusters and unseen matter. The visible disk might stretch about 100,000 light-years across, but the Milky Way's invisible halo could be 10 times larger, extending up to 1,000,000 light-years in diameter. That's the scale of our galaxy's gravitational reach, its invisible hand shaping the space around it. So, how big is it really? The answer depends on what you count. If you count only the bright stars, it's about 100,000 light-years across. If you count the faint halo of stars and gas, maybe 200,000. And if you include the dark matter, the hidden scaffolding that holds it all together, the Milky Way could be nearly 1,000,000 light-years wide. To put that into perspective, light itself, the fastest thing in the universe, would take 1,000,000 years to cross from one end to the other. 1,000,000 years of travel, just to move from one side of home to the other. We often think of the Milky Way as static, like a picture in the sky. But it's alive. The stars are moving, orbiting, colliding, being born and dying in an endless rhythm. The spiral arms are not fixed. They are patterns, density waves that move through the disk like ripples through water. Stars drift in and out of them, brightening the arms where they gather. Over millions of years, the shape of the galaxy shifts and breathes like something living. And through all that motion, our sun and its planets quietly circle the center. One orbit every 230 million years. We've made that journey only about 20 times since our solar system formed. Each time we've gone around, the galaxy itself has changed. New stars have formed, others have gone dark, entire regions of space have shifted. The Milky Way we orbit today is not the same one we began in. It's humbling, isn't it, to realize that our world, our entire history, unfolds inside a single speck of that spiral. That the distance between one side of the galaxy and the other is so great that light itself cannot bridge it in a human lifetime or 1,000 lifetimes. And yet somehow we can understand it. With mathematics, with patience, with the faint glow of starlight, we can measure something so vast that it defies imagination. That's the true size of wonder. It's not just about the numbers, the hundreds of billions of stars, the light years, the rotations. It's about our ability to stand here, on one small planet, and comprehend even a glimpse of it. To take the faint band of light that our ancestors once thought was spilled milk from the gods and reveal it to be a galaxy. A home so large that even the concept of distance breaks apart inside it. When you look up at the Milky Way on a clear night, remember, you are seeing the edge of that vast spiral from within. You are looking through the disk, across thousands of light years, into the crowded lanes of our galactic home. Every point of light you see is a star, and each one could have planets, and each of those could have stories of their own. The Milky Way isn't just a galaxy, it's a measure of human curiosity, of how far we're willing to stretch our minds to understand where we are. And in the next part of our journey, we'll move closer to its heart, to the hidden center, where stars swirl around something so massive and mysterious that even light cannot escape. Until then, take a moment to breathe. You are part of this vastness. A single spark, floating in a spiral of stars, bound together by gravity and time. You are inside the Milky Way, and the Milky Way is inside you. Thank you for joining me on this quiet stretch of the journey. If you're enjoying this series, please leave a like, subscribe, or join as a member to help keep these stories ad-free and unhurried. Sleep well tonight, and dream of the distance that defines our galaxy and the wonder that lets us measure it. If you could step outside the Milky Way, rise up and look down upon it from above, you would see a magnificent spiral of light, curved arms curling around a bright, golden heart. That heart is the galactic center, the place everything else orbits. But for most of human history, that center was hidden from us. Wrapped in clouds of dust and gas, buried behind thousands of light years of stars, it remained invisible, a secret in the heart of home. To find the center of something when you can't see it directly, that's a puzzle only patience and imagination can solve. When Harlow Shapley suggested that the Milky Way's true center lay in the direction of Sagittarius, his claim was radical. It meant that everything we thought we knew about our place in the galaxy had to shift. The Sun, he said, wasn't in the middle at all. It was roughly 25,000 light-years away from the core, far out on the Orion Arm in a quiet suburban corner of the galactic disk. At the time, there was no telescope powerful enough to see through the dust that veiled Sagittarius, but Shapley's idea lingered because it made sense. The globular clusters he mapped seemed to swarm around that unseen point, like bees circling an invisible hive. Somewhere in that direction lay the heart of the Milky Way. Through the mid-20th century, technology began to catch up with imagination. Astronomers learned to look with new eyes, not just through visible light, but through infrared, radio, and eventually X-rays. Each wavelength peeled away a different layer of the galaxy's disguise. In the 1950s and 60s, radio telescopes revealed something remarkable, a powerful source of radio waves coming from Sagittarius, a region near the galactic equator. It wasn't a single star. It was something compact, energetic, and unlike anything else nearby. They named it Sagittarius A. Later, with sharper instruments, they found that within Sagittarius A was an even smaller, more intense source, Sagittarius A star, or SGR-AOR for short. At first, no one knew what it was. Some thought it might be a dense cluster of neutron stars or a region of violent star formation. Others whispered that it might be something even stranger, a black hole. But black holes were, at that time, mostly theoretical. They existed in equations, not yet in evidence. And yet, the clues grew stronger. By the late 20th century, astronomers had begun tracking the motions of individual stars near the galactic center. These stars, seen only through infrared telescopes that could pierce the dust, were moving at incredible speeds, thousands of kilometers per second, whipping around an invisible point. Their orbits were tight and precise, as if bound by an immense gravitational anchor. Over years of careful observation, a pattern emerged. One star, known as S2, completed a full orbit around the unseen center every 16 years. From that motion, scientists could calculate the mass of the object it circled, about 4 million times the mass of the Sun, confined within a region no larger than our solar system. There was only one thing in the universe known to fit that description: a supermassive black hole. That was the moment humanity truly found the heart of the Milky Way. Not just its geometric center, but its gravitational soul. Imagine that, a black hole, 4 million suns worth of matter collapsed into a single invisible point. Around it, stars race in silent loops, light bends and twists, and space itself is pulled into a whirlpool. Yet from Earth, all of this happens in perfect stillness. If you step outside on a summer night and look toward the constellation Sagittarius, you're looking in the direction of the galaxy's core. But to the naked eye, it's only a patch of soft, hazy light. The drama beneath it, the roaring gravitational engine, lies hidden behind curtains of dust. In 2019, we finally saw it. Not with our eyes, but with an array of telescopes scattered across Earth, a collaboration called the Event Horizon Telescope. By combining signals from observatories around the world, scientists created a virtual telescope as large as the planet itself, and with it, they captured the first direct image of Sagittarius A star. The picture wasn't sharp in the way a human photograph might be. It looked like a glowing ring, a halo of light circling a dark center, distorted by the bending of space-time itself. But that blurry orange ring carried the weight of centuries of curiosity. For the first time, We weren't just guessing where the center was, we were seeing it. That faint ring of light marks the boundary where gravity becomes absolute. Inside that ring, not even light can escape. Beyond it, time and space are twisted together in ways we can barely describe. And yet, it is quiet. The black hole doesn't devour everything around it. It sits at the heart of our galaxy, patient and massive, a stabilizing presence rather than a destroyer. The stars that orbit it do so peacefully, each on its own long, graceful path. Sometimes we imagine black holes as monsters, cosmic drains that swallow worlds. But Sagittarius A star is more like an anchor. Its gravity helps shape the motion of the Milky Way itself. It's the still point around which hundreds of billions of stars revolve, the dark heart that holds everything together. To think that we live inside a galaxy balanced around something so paradoxical, so invisible yet so powerful, is humbling. The very idea stretches our understanding of what existence means. A place where light falls inward and never returns, yet whose gravity sculpts the paths of entire star systems, including our own. In a way, the center of the galaxy isn't a place you could ever visit, even if you traveled for thousands of years, even if you could survive the radiation, the tidal forces, the density of stars. You'd never truly see it. You'd arrive at a darkness that isn't a thing, but the absence of everything we can know. And yet, from that darkness, beauty radiates. Around it spin stars, dust clouds, and nebulae, the galactic equivalent of constellations glowing in quiet motion. Astronomers have found that the core of the Milky Way is a bustling region of energy. Stars are born there in clusters, some living fast and bright, others consumed by the gravity that birthed them. Supernovae echo through the dust, sculpting vast arcs and filaments of gas. Magnetic fields twist and shimmer. It's a place of chaos and creation, the galaxy's beating heart. And it's always been there, even before the sun, before the Earth, before life. For over 13 billion years, Sagittarius A star has anchored our galaxy through collisions, mergers, and cosmic storms. It was there when the first stars of the Milky Way ignited. It will be there when our sun dies. When you think of the center now, don't imagine a single point, but a whole region, tens of thousands of light years wide, filled with stars packed more densely than anywhere else in the galaxy. From one of those stars, if you could stand on a planet and look up, the sky would never be dark. It would be woven with light, stars brighter than any we've ever seen from Earth, crowding every direction. That is the true center of the Milky Way. Not just a place, but a state of being, where matter, light, and time bend into a single, infinite curve. And from our small corner, 25,000 light-years away, we orbit it silently. One revolution every 200 million years. We'll never reach it, but every night we can face its direction and know that we belong to something vast, mysterious, and complete. So when you lie down tonight and the world goes quiet, think of that distant point in Sagittarius, that invisible heart, 4 million suns heavy, around which everything turns. You are connected to it by gravity, by history, by the atoms in your blood that were born from stars orbiting that same center billions of years ago. We found the heart of our galaxy, and the more we learn about it, the more it teaches us about ourselves, about what it means to be small and to be part of something immeasurably large. If this quiet journey moved you, please leave a like or subscribe to Space for Sleep. It helps keep these nights ad-free and unhurried so we can keep exploring together. Now close your eyes. Picture that glowing heart hidden behind the dust. Feel the pull of gravity, slow and steady, the same force that keeps your feet on the ground and the stars in their orbits, the same force that connects you to the very center of the Milky Way. Sleep well, traveler. You are home. When you look up at the Milky Way, that faint, river-like band stretching across the night, you're really looking along the flat plane of a spiral. Our home galaxy isn't just a disk of scattered stars. It's a whirlpool of light, curved, layered, alive. From the outside, it would look like a vast pinwheel, arms of starlight and dust curling outward from a luminous center. But from here, inside it, we can only glimpse the pattern. We see the glow edge on, a soft shimmer against the dark, unaware that what we're seeing are the arms of a spiral galaxy wrapping around us. It's beautiful to imagine if we could rise far above the galactic plane, drift in the silence of intergalactic space, and look back, we would see the Milky Way stretched across 100,000 light-years, a golden core surrounded by swirling ribbons of blue-white stars and pink nebulae. It would look delicate, almost fragile, but it is anything but. It's bound together by gravity, a force so gentle you don't feel it, and yet so persistent it can sculpt entire galaxies out of chaos. For centuries, no one knew the Milky Way was spiral-shaped. Even after Shapley found the center, we couldn't see the structure itself. We were trapped inside it, like someone trying to draw a city map while walking its streets. But in the mid-20th century, radio astronomy changed everything. By tracing the faint 21-centimeter emission of neutral hydrogen, the soft radio hum of atoms spread through space, astronomers began to map the unseen. Hydrogen clouds traced the Milky Way's spiral arms, revealing a grand pattern hidden beneath the dust. What they found was breathtaking. Our galaxy has several main arms, though their exact number is still debated. The Perseus arm, broad and majestic, sweeps through the outer regions. The Scutum Centaurus arm curls inward, winding close to the galactic center. Between them lie smaller spurs and bridges, like tributaries of a cosmic river. And our own sun, our quiet neighborhood, sits in a smaller lane called the Orion Arm, or sometimes the local spur. It's not one of the great arms, but a smaller branch connecting them, a peaceful backroad of the galaxy. The spiral arms aren't solid structures. They're more like traffic jams in the galaxy's disk, regions where stars and gas bunch together as they orbit the center. Imagine cars on a highway. The cars move, but the traffic jam itself stays in place. The spiral pattern is a wave, not a fixed shape. As gas and dust drift through it, the compression triggers star formation, bright, young blue stars that light up the arm before quickly burning out. That's why spiral arms glow so beautifully. They're the cradles of newborn stars. Every shining patch of blue light in a spiral galaxy marks a region of creation, a place where clouds of hydrogen have collapsed to give birth to suns. Inside these arms, the life cycle of stars unfolds again and again. Massive stars form, live fiercely for a few million years, and explode as supernovae, their shockwaves triggering the next generation of star formation. The gas that was once inside them returns to the interstellar medium, enriched with heavier elements: carbon, oxygen, iron. From that dust, new stars and planets emerge. Even our own sun was born from such recycled material, atoms once forged in ancient supernovae, mixed and remade into something new. The spiral arms are not just patterns of light, they are engines of renewal, the heartbeat of the galaxy. If you could travel across the disk from arm to arm, you'd see how alive it all is. You'd pass through glowing nebulae, enormous clouds of gas where stars are forming, like the Eagle Nebula, home of the pillars of creation. You'd glide through clusters of hot young stars in the Carina Nebula, then into darker regions where the starlight fades, absorbed by cold dust. The spiral arms aren't clean lines, they're messy, dynamic, full of motion and change. Some regions collapse into new suns, others disperse into emptiness. Over millions of years, the arms twist and shift, driven by the slow turning of the galaxy. The Milky Way rotates, but not like a solid wheel. Each part moves at a different speed. Near the center, stars complete their orbits quickly, pulled by the dense mass within. Farther out, the motion slows, and yet something strange happens. The stars in the outer regions move faster than gravity alone should allow. That mystery, the reason the spiral arms don't simply wind up and vanish, led to one of the greatest discoveries of modern astrophysics, dark matter. An invisible halo of mass surrounds the galaxy, adding gravitational pull where there should be none. Without it, the Milky Way's whirlpool of light would fly apart. So, every time you picture those glowing arms, remember, you're seeing only a fraction of what holds them together. Most of the galaxy is invisible, a quiet scaffolding made of something we still don't understand. The light is just the surface, the thin frost atop an ocean of mystery. From Earth, the Milky Way's spiral pattern is hard to see in full, but we can trace it through careful measurement. Infrared telescopes like Spitzer have peered through the dust to reveal its true outline. They've shown us that our galaxy has a bar, a long, straight bridge of stars running through its center, from which the spiral arms emerge like waves. This bar acts as a gravitational funnel, channeling gas toward the core, fueling star formation near Sagittarius A star. It's as if the Milky Way breathes, drawing in matter, creating stars and exhaling light. The spiral arms also tell us something about time. Each one is like a record of the galaxy's history, preserving waves of star birth that ripple outward over hundreds of millions of years. Our own sun, moving quietly along its orbit, drifts in and out of these arms over cosmic timescales. Sometimes it travels through calm, empty regions, sometimes through busy, bright ones. It's possible that these crossings have influenced life on Earth, bursts of nearby supernovae, changes in cosmic radiation. The galaxy's motion, slow and silent as it seems, may have shaped our planet's story in ways we're only beginning to understand. Think about that for a moment. The sky above you, those gentle, scattered stars, are part of a vast spiral that's turning, slowly but steadily, through space. Every beam of starlight, every cluster, every glowing nebula is part of that same pattern. And you, sitting here, listening, breathing, you're inside it. You are one point within that swirling, luminous whirlpool of light. If you were to rise out of the plane of the galaxy, high above its edge, and look down, you'd see the arms curling beneath you like petals. They'd stretch out in slow arcs, glowing where new stars shine, dimming where dust hides the view. You'd see the sun, a faint yellow star among billions, circling the center like a single grain of sand caught in a cosmic tide. And beyond the disk, faint and ghostly, you'd see the halo, the sphere of old stars and dark matter that encloses everything, extending far beyond the visible light. That's the shape of our home. A whirlpool of light, rotating through the dark, held together by forces both known and unknown. A place of balance and beauty, where creation and destruction happen side by side in silence, over spans of time that make our entire history seem like a heartbeat. So the next time you look up at the Milky Way, remember that you're seeing the edge of something immense. That faint glow is one of the galaxy's arms, the one we live in. You are seeing your place in the spiral, the slow, shimmering wave that's carried our sun for billions of years. And in that thought, there's peace. The universe is vast, yes, but it's also continuous. You belong to a pattern of light that stretches across the stars. You are part of the galaxy's motion, part of its rhythm, part of its endless turning. Thank you for joining me tonight. If this quiet exploration brings you calm, please leave a like or subscribe to Space for Sleep. It helps keep these journeys gentle and uninterrupted, so we can keep drifting through the stars together. Now close your eyes for a moment. Picture that great spiral, its arms glowing softly, turning slowly in the dark. You are inside it, moving with it, part of its luminous flow. The Milky Way turns, and you turn with it, a traveler in a whirlpool of light. If the Milky Way is a vast whirlpool of light, then its edge is where that light begins to fade, where stars grow sparse, gas thins out, and the galaxy dissolves into darkness. It's easy to imagine that a galaxy might end sharply, like the edge of a map or the rim of a coin. But in truth, there is no hard boundary, no clear line between where the Milky Way stops and the emptiness beyond begins. The galaxy simply grows fainter, quieter, until what was once a sea of stars becomes a silent ocean of almost nothing. Finding that edge has been one of astronomy's quietest challenges. It sounds simple. How far does the Milky Way go? But the deeper you look, the more uncertain the answer becomes. Every telescope that peers outward reveals a little more. Faint streams of gas, hidden clusters of old stars, clouds of dark matter extending far beyond the visible disk. The Milky Way's edge isn't a border, it's a blur. Our galaxy's bright disk, the part filled with stars, gas and dust, stretches roughly 100,000 light-years across. That's the part we see glowing as the Milky Way band across the sky. But beyond that, the structure continues. A thick disk of older stars extends farther out, and beyond that, a halo of faint ancient stars and invisible dark matter wraps around everything. If you include that halo, the Milky Way's true size might be closer to 1,000,000 light-years from end to end, 10 times wider than the bright disk we can see. So how do we measure something that fades into darkness? Astronomers use several clues. One is neutral hydrogen gas, which emits a distinct radio signal at a wavelength of 21 centimeters. This signal cuts through the dust that hides much of the galaxy's visible light, letting us trace the distribution of gas far beyond where stars are bright enough to see. Using vast radio telescopes, scientists have mapped the faint hydrogen envelope that surrounds the Milky Way, finding that the disk doesn't stop abruptly. It tapers off gradually, blending into a diffuse outer layer that's hundreds of thousands of light-years wide. Another clue comes from stellar streams, long, thin ribbons of stars that stretch across the sky. These streams are the remains of smaller galaxies that the Milky Way has torn apart and absorbed over billions of years. Their orbits outline the shape of the galaxy's gravitational field, hinting at the size of the unseen halo. One of the most famous, the Sagittarius stream, wraps almost completely around the Milky Way, tracing the path of a dwarf galaxy being slowly pulled apart by our own. In recent years, the Gaia Space Observatory has revolutionized our understanding of the Milky Way's edges. By precisely measuring the positions and motions of over 1 billion stars, Gaia has revealed the galaxy in exquisite detail, not as a flat disk, but as something alive and rippling. The outer regions aren't calm, they're warped and twisted, as if the galaxy's edges are fluttering like a sheet of fabric caught in a cosmic breeze. Some of that motion comes from our neighbors, the large and small Magellanic Clouds, 2 small companion galaxies whose gravity tugs gently at the Milky Way's outskirts. Their pull creates waves that ripple through the disk, bending it slightly upward on one side and downward on the other. If you could travel to that distant edge, what would you see? At first it would look like deep space, empty, silent. But if you waited, if you let your eyes adjust, you'd start to notice faint smudges of light, the last, lonely stars of the galactic disk. They'd be old and red, small embers burning slow in the cold. Gas clouds would drift among them, thin and ghostly. The view toward the galactic center would be breathtaking. A faint golden glow rising from the darkness. The entire Milky Way seen edge on, stretching like a ribbon across the black. Beyond you, there would be nothing. Just the thin halo, almost invisible, and then intergalactic space. That space isn't truly empty, of course. It's filled with traces, single atoms floating across vast distances, the faint radiation left over from the Big Bang, and the invisible web of dark matter that connects galaxies like threads of glass. If you could look back at the Milky Way from that distance, say, 1,000,000 light-years away, you'd see it as a delicate spiral glowing softly in the dark. The arms would appear like silk, curving from a bright core, surrounded by a faint mist of stars barely visible. Our entire home would be just one glimmer in a sea of other galaxies, each spinning in its own slow rhythm. And yet, that edge, that fading boundary, is part of what defines the Milky Way's grandeur. It reminds us that the galaxy is not a closed system. Stars at the edge can escape, drifting into intergalactic space. Gas clouds are pulled outward by neighboring galaxies or stripped away by cosmic winds. At the same time, new material falls in, wisps of hydrogen from the cosmic web, feeding the galaxy, sustaining star formation. The edge of the Milky Way is not a fence, it's a meeting place, a soft horizon where the galaxy breathes in and out. Some astronomers think of that region as the galactic frontier, the place where the known meets the unknown. It's where the Milky Way's gravity still holds sway, but only barely. Beyond it, the pull of other galaxies begins to take over. If you could follow a single atom of gas drifting outward, you'd find that eventually it no longer belongs to the Milky Way. It becomes part of the space between galaxies, the intergalactic medium, waiting perhaps to be gathered into some new world millions of years from now. It's a poetic thought that even at the edge of everything we know, there is motion, exchange, transformation. The Milky Way is not an island. It's part of a cosmic archipelago, a vast collection of galaxies bound together by gravity, each influencing the other in ways subtle and profound. The faint stars at the outer edge remind us that our galaxy has grown over time. It wasn't always this large. In the early universe, it was smaller, tighter, more chaotic. Over billions of years, it consumed smaller galaxies, adding their stars to its outskirts, expanding like ripples spreading on water. Those outer stars, the ones we struggle to detect, are the remnants of those mergers, fossil light from the Milky Way's youth. So, how big is the Milky Way? The truest answer may be this: as big as gravity allows. It extends as far as its pull can reach, as far as its stars and gas can remain bound before drifting into the dark, and even that limit is not fixed. As the galaxy continues to evolve, as it interacts with its neighbors, its edges shift and breathe. Our home is not a static structure, but a living one, expanding, merging, reshaping itself with time. If you ever find yourself under a dark, rural sky, far from the noise of cities, look up toward that pale river of stars. That soft glow is the thick of the disk, but remember, it doesn't end where your eyes stop seeing it. It keeps going, far beyond the reach of sight, into faint star clouds, into the cold halo, and finally into the quiet nothing between galaxies. That's the edge of the disk. Not a wall, but a whisper. The place where starlight fades and imagination begins. And somehow, knowing that edge exists makes the galaxy feel more complete. It's not just an ocean of stars. It's an ocean with a shore, a place where everything we know touches everything we've yet to discover. So tonight, as you close your eyes, imagine drifting outward, past the familiar constellations, past the crowded arms, through the thinning stars until the Milky Way becomes a ribbon of light behind you. You're leaving home, but you're still part of it. Even here, at the edge of the disk, the galaxy's gravity still holds you. You are still connected to every star, every atom, every breath of light. And in that connection lies something beautiful, the reminder that no matter how far you travel, you never really leave the galaxy. You carry it with you, in your atoms, your bones, your memories. You are the Milky Way looking back at itself. If that thought brings you peace, please leave a like or subscribe to Space for Sleep. Your support keeps these cosmic nights calm and ad-free, and lets us keep wandering together through the quiet, endless dark. Now breathe deeply. Picture that horizon of fading starlight, soft, distant, serene. That's the edge of our galaxy, and tonight you are standing right there, watching the last stars dissolve into infinity. If the Milky Way were alive, its heart would beat deep in the dark, unseen, unlit, yet felt everywhere. At the very center of our galaxy, 40,000 light-years from where the sun drifts quietly in the Orion Arm, there lies something extraordinary, a place where light itself cannot escape. It's called Sagittarius I, a supermassive black hole 4 million times heavier than our sun. And somehow, everything in the galaxy, from the smallest atom to the grandest spiral arm, feels its pull. You might imagine a black hole as an enormous vacuum, devouring everything around it. But the truth is subtler and far more beautiful. A black hole is not a monster tearing the galaxy apart. It's a sculptor, invisible, silent, shaping the flow of stars and gas through the sheer weight of its gravity. At the center of the Milky Way, Sagittarius AHO doesn't consume everything, it anchors everything. It keeps the galaxy's course steady, guiding its stars in a vast cosmic waltz. For most of human history, we didn't know it was there. We couldn't. When we look toward the galactic center, the direction of the constellation Sagittarius, our view is blocked by thick clouds of dust and gas. Visible light cannot pass through them. The center of the Milky Way, to our eyes, was a mystery, a glowing band with a hidden heart. That began to change in the late 20th century. Astronomers turned their instruments not to visible light, but to infrared and radio waves, which can slip through the dust. What they found was astonishing. A cluster of stars near the center, moving at incredible speeds, some whipping around an invisible point at thousands of kilometers per second. They were orbiting something massive, yet unseen, something smaller than our solar system, but millions of times heavier than the sun. The only thing that could fit that description was a black hole. One of the most remarkable achievements in modern astronomy came from those observations. By tracking the motion of a single star, S2, scientists watched it swing around that dark center in a 16-year orbit. At its closest, S2 came within just 17 light-hours of Sagittarius ANA, roughly 3 times the distance from the Sun to Pluto. In that moment, it was moving at nearly 3% of the speed of light, and yet the black hole itself remained invisible. We could see only its influence, the way it bent space and time around it. Then, in 2022, after years of work by the Event Horizon Telescope, humanity finally saw it. A global network of observatories, spread across Earth, acted as one giant telescope, capturing the first image of Sagittarius ABAs. What they revealed wasn't a hole in space, but a glowing ring, a blurred, fiery halo of gas swirling around a perfectly dark center. That shadow, that circular absence of light, was the event horizon, the point beyond which nothing can return. To look at that image is to look into the soul of the galaxy. That soft ring of light, 26,000 light-years away, is the closest we've ever come to seeing gravity itself. Every photon you see there is a survivor, a piece of light that skirted the edge of oblivion, bent almost to breaking before escaping toward our eyes. In that sense, the heart of the Milky Way is not just darkness. It's also light, struggling and surviving in the presence of the impossible. But what is a black hole, really? It begins with a dying star. When a massive star runs out of fuel, it can no longer resist its own gravity. It collapses inward, crushing itself into a point so dense that even light cannot escape its pull. That point, the singularity, is surrounded by the event horizon, a boundary marking the edge of knowable space. Once something crosses it, its story ends, at least from our perspective. But at the center of the galaxy, this process has been magnified on a cosmic scale. Sagittarius AHA is not the corpse of one star, but the accumulation of many, fed by eons of gravity, gas, and time. The space around it is anything but still. Hot gas, magnetic fields, and radiation swirl and twist in a glowing storm. Some of it falls inward, some is flung outward at near-light speeds, forming invisible jets that pierce the darkness. Time itself slows near the event horizon. If you could somehow float close to that edge, safely, impossibly, the universe around you would appear to rush forward. Stars would age in a flash. Light would stretch and fade. And then, as you crossed the horizon, everything, time, space, meaning, would dissolve into the singularity's silence. It's strange to think that such a place could exist at the heart of something so beautiful. The Milky Way, all its stars, planets, and nebulae, revolves around this one dark point. Every orbit, every motion, every ripple of gas in the galactic center is guided by it. The black hole doesn't destroy the galaxy, it defines it. And yet it's small, astonishingly small compared to the galaxy's scale. If the Milky Way were the size of North America, Sagittarius ABO would be a single grain of sand at its center. And still, that grain's gravity holds everything together. Around the black hole, there's a dense cluster of stars, some orbiting in chaotic paths, some forming young clusters from collapsing gas. They live in one of the most extreme environments in the universe, bathed in radiation, whipped by gravity, yet somehow still shining. Their light gives the galactic core its golden glow, the bright, dense heart we see in long exposure images of the Milky Way. If you could stand in that region, if you could somehow survive there, the sky would never be dark. Thousands of stars would blaze around you, brighter than any full moon. The black hole itself would be invisible to your eyes, a silent absence surrounded by swirling fire. And if you looked outward, toward the arms of the galaxy, the Milky Way's disk would rise around you like a glowing ring, a horizon of stars circling in endless motion. It's humbling to realize that everything we see, every constellation, every sunrise, every atom in your body, is part of a dance centered on that darkness. We live in the outskirts of a galaxy whose heartbeat is a gravitational collapse, and yet, without it, there would be no Milky Way at all. So, the next time you see the soft band of light stretching across the night sky, remember, that glow curves around a shadow. At the heart of that beauty lies a place where time stands still, a reminder that even in darkness, there is structure, meaning, and awe. The heart of darkness is not a void, it's a foundation. It's where the galaxy's rhythm begins. And somehow, even knowing that it's invisible, we can feel it in the way the stars move, in the quiet hum of gravity that connects us all. If you've made it this far tonight, thank you. Your curiosity, your calm attention are what keep this space alive. Please, if you enjoy these quiet explorations, leave a gentle like, subscribe to Space for Sleep, or become a member to support these ad-free nights beneath the stars. It truly helps keep this channel glowing, like the ring of light around Sagittarius A. Now take a deep breath, close your eyes. Imagine that black hole glowing softly in the dark, a golden ring, endless and still. The galaxy turns around it, slowly, silently. And somewhere out there, among billions of stars, one small planet dreams of understanding. If you hold a single grain of sand in your palm, you're holding something that barely registers on the scale of the universe. Yet if you had enough grains, piled high enough, they'd begin to matter. Their weight would press into your skin. Now imagine 1 trillion such grains, glowing, burning, orbiting in silence. That, in a sense, is what the Milky Way is. A weight so vast it curves the fabric of space-time itself. We've spent centuries learning what the galaxy looks like. Its spiral arms, its stars, its glowing heart. But knowing what something weighs tells a different kind of story. Weight reveals structure, it reveals the unseen. And the deeper astronomers have looked, the more they've realized something astonishing. Most of the Milky Way's mass, its weight, is invisible. When you look at the night sky, everything you see, every star, planet and nebula, is made of normal matter, the kind we're familiar with. It glows, it reflects, it interacts with light. But that glowing matter, all of it combined, accounts for only a small fraction of the galaxy's true mass. The rest is hidden, silent and dark. Let's start with what we can see. Our galaxy contains somewhere between 100 and 400 billion stars. Each of those stars is a massive sphere of gas, and together they weigh about 60 billion suns worth. Then there's the gas and dust between the stars, the raw material for new solar systems. Add that, and the total climbs a bit higher. So far, so normal. But when astronomers began measuring how fast stars orbit around the galaxy's center, something didn't add up. According to Newton's laws, stars farther from the center should move more slowly, just like planets far from the sun have longer, slower orbits. Yet when we measured them, the stars near the outer edges weren't slowing down. They were moving too fast, as if something massive and unseen were pulling on them. This was one of the first hints of dark matter, the invisible glue that holds galaxies together. We can't see it, we can't touch it, but we can feel its gravity. Without it, the Milky Way would fly apart like embers blown from a fire. With it, the galaxy stays whole. So how heavy is the Milky Way, really? Estimates vary, but the best measurements suggest our galaxy weighs roughly 1 trillion solar masses. That's 1 trillion suns, a number so large it almost resists comprehension. But here's the strange part. Of that trillion, only about 1/6 is made of normal matter. The rest, 5/6, is dark matter, completely invisible to light. It's humbling to think that the vast spiral of stars we see in the sky is just the visible tip of something much larger. It's like seeing the surface of an iceberg, bright, detailed, and familiar, while the greater mass lies hidden beneath the waves. The Milky Way's visible disk, the part we can photograph and map, is only a fraction of its true body. Wrapped around it is an enormous spherical dark matter halo, extending hundreds of thousands of light years in every direction. This halo doesn't glow or absorb light, but it exerts gravity. We can measure its influence by watching how stars, gas clouds, and even satellite galaxies move around us. Their orbits trace the contours of an invisible field, the ghostly outline of the Milky Way's weight. And it's not just dark matter that makes the galaxy heavy. The interstellar medium, the space between stars, is filled with gas and dust that together weigh as much as tens of billions of suns. That material is constantly cycling, collapsing to form new stars, then being blown apart again by supernovae, spreading heavy elements through space. This circulation, this breathing of matter in and out of stars, gives the galaxy its life, but also contributes to its total mass. Even black holes add their share. The supermassive black hole at the center, Sagittarius R8, holds about 4 million solar masses. That's a small fraction of the whole, but it shapes the very center's dynamics. And scattered through the galaxy are smaller black holes, the remnants of dead stars, perhaps hundreds of millions of them, each one adding a small but meaningful contribution to the Milky Way's invisible weight. So, if you could somehow place the entire Milky Way on a cosmic scale, the needle would swing far past anything we can imagine. But the act of weighing it isn't straightforward. There's no scale, no surface to stand on. Astronomers must infer the weight through motion, through gravity's fingerprint. Every orbit is a clue. Every velocity, every wobble of a star tells us something about the mass that must be there to cause it. To do this, scientists use what's called a rotation curve, a graph showing how fast stars orbit at different distances from the center. If the galaxy's mass were only in the visible disk, those speeds would drop off sharply toward the edges. Instead, the curve stays flat, meaning there must be more mass out there, extending far beyond the stars we can see. That's the dark matter halo, the unseen structure that makes the Milky Way as large as it truly is. In some ways, that discovery reshaped how we think of galaxies entirely. They are not delicate spirals of light floating in a void. They are colossal, gravitational ecosystems, mostly dark, faintly glowing at the surface, like lanterns surrounded by glass. It also tells us something profound about ourselves. The Sun, and Earth with it, orbits the Milky Way's center once every 230 million years. With each orbit, we trace the galaxy's weight, feeling its invisible gravity with every moment that passes. That gravitational field doesn't just hold stars, it holds us. Every step you take, every breath, every falling leaf, every tide, all are guided by the same force that keeps the Milky Way intact. When you think of that, the word weight takes on new meaning. It's not just a measure of how heavy the galaxy is, it's a measure of how deeply it connects everything within it. Every particle of dust, every ray of light, every orbiting world contributes to a single bound system, balanced by gravity's gentle hand. Sometimes, when astronomers describe the galaxy's mass, they use the phrase, the Milky Way's gravitational potential. It's a quiet phrase, but a beautiful one. It means that the galaxy's weight is not just what is, but what could be. It describes the space in which stars move, the invisible landscape carved by mass and time. It's the reason gas clouds collapse, the reason stars form, the reason orbits exist at all. And in a poetic way, that's true of us too. We live inside that potential. We are shaped by it. Our atoms, born from ancient stars, are caught in the same invisible field, part of the same galactic balance. When we look up and wonder how big the Milky Way is, we are also asking, Abracao, how deep is its gravity? How wide is the field that holds us? Astronomers are still refining the answer. New missions, like Gaia and future radio arrays, will help map the outer halo in more detail. Each new measurement brings us closer to understanding the galaxy's full scale and its full weight. But even now, we know enough to be astonished. Our galaxy weighs 1 trillion suns. It's massive enough to hold on to billions of worlds, yet delicate enough to spiral gracefully through the cosmos. So the next time you gaze up at the Milky Way, remember, Abracao. You are looking at something that bends light, curves time, and holds entire systems in its arms. It has mass, vast, quiet, and invisible. And that weight is the reason you can stand on Earth and look up at all. If this moment of cosmic balance brings you peace, please leave a like or subscribe to Space for Sleep. Every gesture of support helps keep these long, ad-free nights alive, a way for curiosity to rest without hurry. Now close your eyes, take a slow breath, and feel the weight of the galaxy, not pressing down, but holding you gently in place. You're floating inside something immense, something ancient. You're part of its gravity. And that, in every quiet sense, is what it means to belong. If the Milky Way were a body, the bright disk of stars would be its skin, delicate, glowing, alive. But beneath that skin lies something vast and invisible, a hidden framework, an unseen architecture holding everything together. It's made not of light, not of atoms, but of something stranger, something we only know by its pull. We call it dark matter. It doesn't shine, it doesn't reflect, and it passes through ordinary matter almost as if it isn't there. And yet, without it, galaxies like ours couldn't exist at all. Dark matter is the silent majority of the universe, the unseen mass that outweighs all stars, planets, and gas combined. It is, in the most literal sense, the invisible giant that shapes the Milky Way. If you could somehow turn off all the light in the galaxy, every star, every glowing cloud, and see only the gravity, you'd find that the Milky Way isn't a flat spiral at all. It's a great sphere, a halo of dark matter surrounding everything we know, extending far beyond the visible edge. That halo may reach out hundreds of thousands of light years, fading slowly into intergalactic space. It's not made of gas or dust. It doesn't collide or clump the way normal matter does. Instead, it forms a smooth, ghostly shell, a gravitational bubble that cradles the entire galaxy inside. The strange thing is, we've never seen a single dark matter particle. We don't know what it's made of. We only know it's there because of how it bends space and guides motion. Stars at the edges of the Milky Way move faster than they should. Galaxies orbiting nearby are tugged by invisible hands. Light from distant quasars bends around invisible shapes. And when we simulate the universe on computers, galaxies like ours only form properly when we include vast amounts of dark matter. It's as if the cosmos refuses to make sense without it. So what might this mysterious substance be? There are theories, elegant, hopeful guesses. Some scientists think dark matter could be made of exotic particles called WIMPs, weakly interacting massive particles, that barely touch ordinary matter. Others propose axions, incredibly light particles that could fill all of space like a silent fog. Some even wonder if gravity itself might behave differently on galactic scales, and that what we call dark matter is really a reflection of a deeper law of physics we haven't yet understood. Whatever it is, dark matter is everywhere. It flows through you, through your room, through Earth itself, passing unnoticed, billions of particles per second, leaving no trace. It doesn't collide, it doesn't scatter, it simply moves, following the pull of gravity like an invisible tide. And together, all that dark matter forms the scaffolding of the universe. Every galaxy, every cluster, every filament of cosmic web, all are built on its structure. The luminous universe, the one we see through telescopes, is just the decoration. The dark matter is the foundation. For the Milky Way, this foundation is immense. Imagine our galaxy's bright spiral disk, 100,000 light-years wide. Now wrap it in a sphere of invisible mass 10 times larger. That's the dark matter halo. It extends far beyond the farthest stars, encompassing even the Magellanic Clouds, our small companion galaxies. They orbit within this halo, drawn not by the light we see, but by the unseen gravity that binds them. When we map the motion of distant globular clusters, ancient balls of stars that drift in the halo, we see their paths curve in ways only a vast spherical gravity field could explain. Those clusters are like fireflies tracing the shape of an invisible dome. By studying their motion, we begin to draw the outline of something we cannot touch. It's eerie, in a beautiful way, to think that the Milky Way we know, the glowing disk that fills our sky, is only a small, bright seed inside a much larger, darker structure. Our galaxy's spiral arms are the surface ripples of a deep, unseen ocean. Beneath them, the dark matter halo holds hundreds of billions of suns' worth of mass, spreading outward in a smooth, quiet field. And this halo is not just static. It's alive in its own slow rhythm. Over billions of years, it's been stirred and reshaped by collisions with other galaxies. Each merger, each passing dwarf galaxy, leaves ripples in the halo, faint gravitational waves, gentle distortions, like a pond disturbed by falling leaves. Some astronomers think the halo even vibrates, like a drum, its density subtly shifting as the Milky Way interacts with its neighbors. When you imagine the Milky Way's size, it's easy to picture the bright parts, the disk, the arms, the glowing center. But the truth is, the galaxy's real boundary is defined not by light, but by gravity. It ends where the dark matter halo's pull fades into the pull of other galaxies. In that sense, the Milky Way's edge is a kind of truce, a place where our galaxy's invisible influence meets the invisible influence of another. And the scale is staggering. If you could travel to the edge of the halo, you'd be roughly 500,000 light-years from Earth, 5 times farther than the farthest stars in the disk. The starlight from there would be dim, scattered, almost lost against the black. You'd be floating in a space that looks empty but isn't, a sea of invisible mass shaping everything you see. It's humbling to realize that we live deep inside this hidden world. Every orbit we trace, every light we see, every cosmic event we witness happens inside a halo of darkness. And that darkness isn't a void, it's structure. It's what keeps the galaxy whole. In a way, the dark matter halo is like the night itself. You can't see it directly, but it gives everything else its contrast, its depth, its meaning. Without darkness, light would have nowhere to shine. Without the invisible halo, the Milky Way's beauty would scatter into the void. So the next time you stand beneath the stars and trace that milky band across the sky, remember, see free. You're looking at the light resting gently on the surface of something immense and unseen. The galaxy doesn't just glow, it floats, suspended in a web of gravity too subtle for our eyes, but not for our understanding. If this glimpse into the invisible has brought you calm curiosity, please leave a like, subscribe, or become a member of Space for Sleep. Your support keeps these explorations ad-free, slow, and thoughtful, made for minds that love both science and serenity. Now take a slow breath. Imagine the galaxy all around you, the luminous arms within, the quiet halo beyond. You're floating not just among stars, but within the vast, invisible ocean that holds them. The halo hums softly, in the language of gravity. And in that hum, there's a quiet reminder. The universe is deeper than what light can show. There's a kind of loneliness at the edge of the Milky Way. Out there, beyond the bright arms, the stars grow sparse and scattered. The galactic light fades into a quiet mist of time. And if you listen closely, in the language of motion, of orbit, of faint starlight, you can almost hear whispers, the whispers of old galaxies long ago devoured. The stellar halo is one of the Milky Way's most mysterious features. It's not the dark matter halo, though it floats within it, shaped by it. This halo is made of stars, faint, ancient ones, drifting in enormous orbits far from the galactic plane. Some are so far away they take billions of years to complete a single revolution around the center. They are survivors of a different age, the fossils of cosmic history. When astronomers first studied these distant stars, they noticed something strange. Their chemistry was different, poorer in heavy elements than stars like our Sun. They were made of almost pure hydrogen and helium, with only traces of other elements. In the quiet language of astrophysics, this meant they were old. Born before the Milky Way had enriched itself with generations of stellar deaths. They were the galaxy's elders, ancient, dim, and cold. But there was something else. Their motions didn't match the elegant rotation of the disk. They moved in odd, looping orbits, some plunging straight through the galactic plane, others tilting at steep angles. They weren't part of the smooth spiral at all. It was as if they had fallen in from somewhere else. And that's exactly what happened. Our galaxy, like all galaxies, is a collector of worlds. Over billions of years it has grown not just by forming new stars, but by absorbing smaller galaxies that wandered too close. Each collision tore those galaxies apart, scattering their stars into the halo like spilled sand. The Milky Way is built from the remains of countless others, a cosmic mosaic made of past lives. Some of these ghosts are still visible. The Sagittarius dwarf galaxy, for example, is one such visitor being torn apart right now. Its stars stretch across the sky in a vast looping stream that wraps around the Milky Way like a ribbon. You can't see it with your eyes, but it's there, a faint flow of starlight tracing the memory of a galaxy's slow death. And it's not alone. Astronomers have found many of these stellar streams, delicate rivers of stars winding through the halo. Each one tells a story. Each one marks the place where gravity, over eons, has pulled another galaxy into the fold. Some are the remnants of ancient globular clusters, tight swarms of stars shredded by tidal forces. Others are pieces of galaxies that once had their own dark matter halos, their own centers, their own identities. When we map these streams in 3D, the halo comes alive. It's not an empty shell, it's a living archive of galactic evolution. You can almost picture the Milky Way's outer regions as a vast museum, each faint trail of stars a display case of cosmic memory. And among those memories are clues to how our galaxy grew. By measuring the orbits of these stars and their chemical fingerprints, astronomers can reconstruct ancient collisions, not through images but through data, like detectives studying the wreckage of forgotten worlds. They've even named some of the great mergers. Ea Brye, Gaia Enceladus, a massive collision about 10 billion years ago, whose debris now fills much of the halo. The Helmi streams, Sequoia, Nix, poetic names for events that shaped everything we see today. It's strange to think that when you look up at the Milky Way, many of those stars, quiet, distant, flickering in the dark, don't actually belong here. They're visitors from long-vanished galaxies, drawn into our gravity, now moving as part of a new whole. Each one carries the DNA of a universe that no longer exists, and in a sense, so do we. The atoms in your body, the carbon in your cells, the iron in your blood, were forged in stars that might once have belonged to other galaxies before they became part of this one. The Milky Way's growth isn't just a story of stars, it's a story of identity, of what it means to become something larger through loss and connection. When astronomers look at the halo, they see not just structure but emotion. It's a place of endings and beginnings, of slow, graceful collisions where galaxies dissolve into each other, not with explosions, but with the quiet blending of light. Every faint halo star is a memory that refused to fade. And the scale is staggering. The stellar halo stretches out hundreds of thousands of light years, farther than the disk, fading into the dark matter's domain. It's so diffuse that if you gathered all its stars together, they'd barely outshine a single bright region of the galactic core. And yet, those few scattered lights hold the secrets of our entire formation. We used to think the Milky Way was steady, unchanging, a great wheel of stars spinning in eternal calm. Now we know it's more like a tide, constantly reshaping itself, gathering fragments of what it consumes. The halo is where that story is written. It's where we can still see the fingerprints of creation. Even tonight, as you lie beneath the sky, the Milky Way is still growing. Small dwarf galaxies at the edge of our halo are slowly being pulled in, their orbits decaying as they spiral closer. In the next few billion years, they'll stretch into streams of light, blending with the stars that came before. The process is gentle on cosmic timescales, a slow merging, like the blending of fogs in morning air. Our galaxy, in its vastness, is not static. It's alive. It breathes through motion, through gravity, through the constant exchange of matter and energy. And in that exchange, there's a lesson about resilience, about how beauty often comes not from perfection, but from the gentle accumulation of what has been lost and found again. If you find peace in that thought, in knowing that even galaxies grow through connection and memory, take a moment to breathe. Let the idea settle. You're part of this grand inheritance, a being made of ancient starlight, floating within a halo of forgotten worlds. And if you'd like to keep wandering through these quiet cosmic stories with me, please leave a like, subscribe, or become a channel member of Space for Sleep. Your small gesture keeps this space ad-free, calm, and dedicated to minds that dream between science and stillness. Now, close your eyes. Picture the Milky Way's vast halo stretching outward in every direction, faint, silent, endless. Each tiny point of light is a memory of something that once was. And you, too, are part of that memory. Out here, at the far edges of the Milky Way's halo, the stars begin to thin. The familiar spiral fades into silence, until only a few lonely suns remain, tiny, shimmering outposts of light adrift in an ocean of black. You might think you've reached the end of our galaxy, but beyond that dark horizon, other islands of light begin to appear. Our galactic neighborhood is vast, and it's far from empty. When we step back, not just a little, but by millions of light years, we see that the Milky Way is part of a quiet family, a small gravitational community called the local group. It's home to about 50 or so galaxies, most of them small, dim, and ancient. They gather not in neat rows or clusters, but in a loose, three-dimensional web of motion, a dance choreographed by gravity itself. And at the center of that dance are two giants, Hebrae, our own Milky Way, and our great companion, Andromeda. They are sisters, equal in scale and power, orbiting each other across a gulf of about 5 million light-years. In cosmic terms, that's not far at all. It's a distance our descendants' will one day see shrink to nothing, when the two galaxies finally merge into one. But for now, they remain apart, drifting in the dark, slowly moving toward each other at nearly 110 kilometers per second, silent, inevitable, and patient. Between them lies a vast region of intergalactic space, not empty, but filled with a tenuous haze of hot gas, drifting stars, and invisible dark matter filaments connecting their halos. If you could somehow float there, halfway between the Milky Way and Andromeda, you'd see both galaxies hanging opposite each other in the black, two spirals glowing like faint lanterns in the void, each surrounded by clouds of small companions. And those companions have names that sound almost poetic. The Magellanic Clouds, Draco, Sculptor, Carina, Leo Waffus, Leo II. Tiny dwarf galaxies, some irregular and chaotic, others spherical and ancient. Most of them orbit the Milky Way in gentle ellipses, while others are bound to Andromeda. They are like satellites to giants, small, luminous witnesses to the slow gravitation of time. The large Magellanic Cloud and the small Magellanic Cloud are the brightest of these companions, so bright, in fact, that they can be seen with the naked eye from the southern hemisphere. From Chile, or South Africa, or Australia, they look like pale smudges in the sky, soft, ghostly patches of light just beyond the Milky Way's edge. They are dwarf galaxies in their own right, orbiting us at about 160,000 and 200,000 light-years away. Each contains billions of stars, and together they are connected to us by a trail of gas called the Magellanic Stream, a long ribbon stretching across the heavens, stripped away by the Milky Way's pull. This is what gravity does at the scale of galaxies. It doesn't rip or tear quickly. It tugs gently, slowly, persistently, shaping everything over billions of years. It's less like a collision, more like a slow embrace. Our galaxy's neighborhood isn't just a place of stillness, though. It's alive with motion. The Magellanic Clouds orbit the Milky Way, sometimes approaching, sometimes drifting away. Small dwarf galaxies occasionally pass close enough to stir our disk, bending it slightly, warping its edges, and in return, the Milky Way pulls them apart, their stars spilling into long, delicate trails. It's a quiet, graceful violence, the kind that happens too slowly for eyes to see, but not too slowly for eternity to record. Andromeda has its own retinue of small companions, M32, M110, and a few dozen faint dwarfs that cling to its halo like cosmic dust. Together, Andromeda and the Milky Way dominate the local group, surrounded by smaller members who drift in their gravitational care. If you zoom out further, the pattern begins to repeat. Our local group is part of a larger structure, the local sheet, and beyond that, the Virgo supercluster, a massive web of galaxies stretching hundreds of millions of light-years across. From that scale, even our entire Milky Way becomes nothing more than a bright grain of dust in a vast, luminous fabric. But tonight, let's stay close. Close enough to feel the quiet companionship of our neighbors. Because even galaxies, it seems, are not solitary creatures. They live in groups, in families, connected by invisible bonds that stretch across space and time. And there's something deeply comforting about that. The same force that binds your feet to the Earth is the one that holds the Milky Way and Andromeda in their long embrace. Gravity is the universe's most patient artist, shaping everything it touches with gentleness and inevitability. In that slow pull between galaxies lies a cosmic reflection of something familiar, the way all things drift toward connection. When you look up at the night sky, every faint smudge, every glowing patch of light beyond our stars could be another galaxy, another island of suns and worlds, another home for questions like ours. The universe, seen this way, becomes not a void, but a community, an endless neighborhood of curiosity and light. And here we are, inside one of its homes, looking out through the windows of our own galaxy. For all our science, for all our maps, we've barely explored the backyard. But we know this much: the Milky Way does not float alone. It moves with others, bound by unseen hands, part of a living, breathing structure too big for our minds, but not too big for our wonder. If that thought brings you calm, the idea that even galaxies are held together by gravity and grace, then maybe take a deep breath. Let your mind drift like the Milky Way drifting through its local group. And if you'd like to stay for more of these quiet cosmic journeys, please like this video, subscribe or support Space for Sleep as a member. Your kindness keeps this space ad-free, calm and timeless. Now, close your eyes and imagine it. Two galaxies facing each other across a gulf of darkness, slowly, silently moving closer. The Milky Way and Andromeda. Two great spirals on a slow-motion collision course, their stars destined to mingle. And in that vast, inevitable dance, there's a strange serenity, the kind only the universe could compose. Everything moves. Even the things that look still are only pausing long enough for us to catch them in a single frame. The rocks beneath your feet, the moon above your roof, the planet beneath the stars, all in motion, And the Milky Way, our entire galaxy, is no exception. It too spins, it too travels, it too breathes. If you could rise far enough above the galactic plane and watch it from the outside, you'd see a magnificent spiral, turning slowly in the dark. But slowly here is an illusion. The Milky Way rotates at nearly 220 kilometers per second, fast enough to circle its entire disk once every 230 million years. That means since the dinosaurs roamed Earth, the Sun and its planets have only made about one full orbit around the galaxy. Just one. Every time you look at the night sky, you're sitting on a world sailing through a cosmic current that never stops flowing. The Milky Way doesn't rotate like a solid wheel. It's a fluid system, a vast ocean of stars, gas, and dark matter. The inner regions spin faster than the outer ones, but not as much as you'd expect. That's one of the great clues that dark matter is there, keeping everything bound together in its gravitational grip. Without that unseen mass, the outer stars would fly off into space like sparks from a spinning ember. Our Sun, tucked away in one of the spiral arms called the Orion Arm, moves with this rotation. It orbits the galactic center from a distance of about 26,000 light-years, making its long journey through a sea of billions of other stars. Every star in the sky is also in motion, circling, weaving, drifting, each one tracing its own path through the Milky Way's invisible geometry. If you could see these paths, not as separate lights, but as trails through time, the galaxy would look like a luminous whirlpool of motion. Every orbit, every cluster, every wave of gas forming new stars, all flowing together like the gentle currents of a cosmic tide. The spiral arms themselves aren't made of fixed stars. They're waves, density waves, regions where stars slow slightly and cluster together like traffic jams in space. New stars form within them, lighting them up for a few million years before drifting onward, leaving the spiral arms to form anew. This means that the shape we call the Milky Way is never the same twice. It's constantly renewing itself, forming, fading, and reforming, all while spinning silently through the void. And yet, that spin is only one layer of motion. The entire galaxy itself is moving through space, orbiting within the local group, pulled gently toward the Andromeda Galaxy, and together with it, falling toward the Virgo cluster of galaxies beyond. In fact, our whole local group is rushing towards something even larger, the Great Attractor, a massive region of space whose gravity pulls entire superclusters toward it. So while you're sitting here, breathing slowly, perhaps lying under a blanket, you are moving, not just a little, but profoundly. Right now, as you listen, you are orbiting the Sun at 30 kilometers per second. The Sun is orbiting the galactic center at 220 kilometers per second, and the Milky Way itself is moving through space at over 600 kilometers per second relative to the cosmic background. Add those together, and even when you think you're still, you're hurtling through the universe at unimaginable speed. But it doesn't feel that way, does it? Because everything around you, your planet, your star, your galaxy, is moving with you. You are part of the flow. And in that flow, there's no wind, no drag, no edge to push against, only the quiet drift of existence itself. Astronomers sometimes call the Milky Way a galactic ecosystem, not just because it has structure and life, but because it has balance. Gas clouds collapse to form stars. Stars live, shine, and die. Their deaths spread heavy elements back into the galaxy, enriching the next generation of stars. Supernovae seed the spiral arms with shock waves that trigger more births. It's a cycle of creation and renewal that has been going on for nearly 13 billion years. When we look at it this way, motion isn't just a matter of mechanics. It's a kind of heartbeat. Every orbit, every rotation, every collision and merger, all part of a greater rhythm. The Milky Way, in its quiet turning, is alive with that pulse. It's not just spinning, it's evolving. If you could somehow listen to that motion, it might sound like a low hum, a galactic breath stretching across time, The stars rising and falling in the disk, the gas streaming through spiral arms, the halos stirring as dark matter ripples. Together, they make the music of motion. It's a song we can't hear, but one we feel, in the curiosity that draws us to look up, in the gravity that keeps us tethered to this spinning world. And if you let your mind wander for a moment, if you close your eyes and imagine the galaxy as it truly is, you might see it not as something far away, but as something you're within. Because you are. You are inside the Milky Way's living body, orbiting with billions of others in a vast, luminous swirl. You are part of the motion, a small consciousness riding the great rotation of a galaxy that's older than all memory. So take a slow breath. Feel that stillness, knowing it's only the illusion of balance in a world forever moving. And when you look up at the night sky, remember, those stars are not fixed points, but companions on a shared journey, drifting with you together through a galaxy in motion. If this brings you calm, or if you find wonder in knowing that even stillness is part of movement, please leave a like, subscribe, or become a member of Space for Sleep. Your support helps me keep creating these quiet explorations where science meets serenity. Now, drift a little. Let the idea sink in. You are a passenger on a spinning star, inside a spinning galaxy, moving through a spinning universe. And in all that motion, there's peace. Because everything moves together. If there's one thing that makes our home galaxy mysterious, it's this. Brew, we've never seen it. Not really. We've seen other galaxies. Majestic spirals, glowing disks, swirling arms of light suspended in black space. And in them, we recognize a reflection of what our own must look like. But the Milky Way, we live inside it. We're like fish trying to imagine the shape of the ocean, or travelers on a foggy mountain who can only glimpse a few trees at a time. From our position, 26,000 light-years from the center, the galaxy stretches around us in all directions. Every star we see in the night sky is part of it. Near or far, bright or faint, each one a single pixel in the vast picture we're trying to reconstruct. To map the Milky Way is to imagine a cathedral from the inside, knowing you'll never step outside to see its full architecture. Early astronomers faced this challenge without the luxury of modern tools. They could only count stars and guess at their distribution. In the 18th century, William Herschel, with his homemade telescopes, tried to chart the galaxy's structure by counting how many stars he saw in different directions. He believed the Milky Way was a kind of flattened disk and that we lived near its center. He wasn't wrong about the shape, only about our place within it. We were far from the center, quietly orbiting on the outer arm, looking inward through layers of light and dust. It took centuries to peel back that illusion. The main obstacle wasn't the lack of stars, but the presence of dust. Vast clouds of microscopic particles scattered through the galactic plane, blocking visible light and hiding the true shape of our home. To the human eye, and even to early telescopes, the Milky Way seemed like a fog of stars with no clear boundaries. But then we learned to see differently. In the early 20th century, Harlow Shapley used globular clusters, those ancient spherical swarms of stars, as markers to locate the galaxy's center. He realized they were not evenly spread. They formed a great halo around a point in the constellation Sagittarius. That point, he concluded, was the galactic heart. And with that revelation, our cosmic perspective shifted forever. Later, radio astronomy took over. In the 1950s, astronomers began to map the galaxy not with light, but with radio waves, specifically the 21-centimeter line emitted by neutral hydrogen gas. Unlike visible light, radio waves pass straight through dust. By measuring these signals, scientists could trace the spiral arms from within, like explorers mapping the corridors of a labyrinth by echo. It was the first time humanity began to see the Milky Way's true shape, a spiral, grand and asymmetric, its arms winding through space like cosmic rivers. Today, we map the galaxy with exquisite precision using satellites like Gaia, a European Space Agency mission that measures the positions, motions, and distances of over 1.8 billion stars. With Gaia's data, astronomers can build a 3D map of the Milky Way, a map not of imagination, but of measurement. Every star becomes a coordinate, a moving point in a living model of our galaxy's architecture. We can watch stars orbit the center, trace the waves rippling through the disk, and even detect subtle wobbles caused by ancient collisions. But even with all this technology, mapping the Milky Way remains a bit like trying to understand a forest by looking through its trees. We can't step outside to see the whole pattern. We infer, we reconstruct, we listen to the light that reaches us. Starlight, radio light, X-rays. Each wavelength revealing a different layer of the galaxy's anatomy. Infrared light shows a stars hidden behind dust. Radio waves trace the cold hydrogen clouds that form new suns. Gamma rays reveal the violent edges of supernovae. Piece by piece, these images combine into something breathtaking, a portrait of our home made entirely from echoes and shadows. Imagine that, a civilization that can map a galaxy it has never seen. It's like describing a whale from the ripples it leaves in the water, or a city from the echoes of its footsteps. Every data set, every photon we collect, becomes part of a larger truth, that even without leaving home, we can still understand the vastness that holds us. And yet, even with all we've learned, the Milky Way continues to surprise us. Gaia's maps have revealed strange warps and ripples in the galactic disk, suggesting that something, perhaps the passage of the Sagittarius dwarf galaxy, has stirred our home in the recent cosmic past. It's as if the galaxy remembers its collisions, not in broken pieces, but in subtle waves of motion. When you see the Milky Way stretch across the sky, that soft band of silver light, you are looking edge-on into the disk through thousands of light-years of stars and dust. Every pinpoint of light is part of the structure we're still trying to define. And all of it, every glowing atom, every shadowed nebula, every orbiting star, is moving, part of a living system so large we can only understand it by patient, cumulative seeing. If you ever feel small, remember this, Yebrichi. You are not outside the map, you are inside it. The Earth, the Sun, the human mind that dreams of galaxies, all of it is woven into the Milky Way's coordinates. We are not observers of the galaxy, we are participants in its dance. So tonight, if you find yourself lying awake, let your imagination float above the stars. Picture the Milky Way's vast shape unfolding beneath you, its arms curling like soft smoke, its center glowing with old light. Know that somewhere astronomers are mapping those very curves, one data point at a time, turning the invisible into understanding. If this story of exploration and patience feels soothing, if it helps you drift between wonder and rest, please leave a like, subscribe, or support Space for Sleep as a member. Your quiet gesture keeps this journey ad-free and unhurried, built for minds that find peace in the vast and the mysterious. Now, breathe in. Let the idea of scale dissolve around you. You are not lost in the galaxy, you are part of the map, a tiny coordinate in a living sea of stars. When we imagine the Milky Way, we often picture a perfect spiral, symmetrical, balanced, its arms unfolding evenly like petals of light in the dark. But the truth is softer, stranger, more alive. The Milky Way is not a flat, still disk. It's warped, bent, and twisting ever so slightly, as though the galaxy itself is rippling like fabric caught in a cosmic breeze. From our perspective inside it, that warp is invisible to the naked eye. But astronomers, tracing the outer layers of gas and stars, have discovered something remarkable. Brie. The galaxy's disk is not straight. It bends on one side and downward on the other, like a slowly turning wave. If you could step far enough away to look back, millions of light years out, you'd see the Milky Way curving gracefully, its edges tilted like the brim of an ancient spinning hat. What could bend something so vast? Gravity, the unseen hand that sculpts everything in the universe, from raindrops to galaxies. Our Milky Way has not lived a peaceful life. It has danced, collided, and merged with smaller galaxies for billions of years. Each encounter, each gravitational handshake, leaves an echo. Those echoes ripple through the galactic disk, twisting it gently out of alignment. One of the main culprits is a small companion galaxy called the Sagittarius Dwarf Galaxy. It's a faint, ghostly collection of stars currently being torn apart by the Milky Way's gravity. As it passes through our galaxy's outer regions, its mass pulls at the stars and gas in our disk, tugging them upward and downward. Like a pebble dropped in water, it creates waves that take hundreds of millions of years to fade. But there may be another player in this celestial dance. Astronomers now suspect that dark matter, the invisible halo surrounding our galaxy, might not be uniform. If this vast halo of unseen mass is uneven or lumpy, it could also twist and warp the disk, gently bending it as the galaxy moves through its own invisible cocoon. We can't see dark matter, but we can trace its effects in the way our stars move. The warp, in this sense, is a kind of shadow, a physical signature of something we cannot yet touch or see. Even the spiral arms themselves aren't static. They breathe, expanding and contracting over time. As the Milky Way orbits, the arms may shift slightly, their shapes guided by gravitational tides and star formation waves. The galaxy isn't frozen, it's alive, reshaping itself as new stars ignite and old ones die. Imagine standing above it all, far above the galactic plane, looking down. You'd see a luminous disk about 100,000 light-years wide, but with its outer edges curling upward by a few thousand light-years. You might notice faint streams of stars arcing away, remnants of past collisions. They look like wisps of smoke, like scars from old encounters. Each stream tells a story, a time when another galaxy passed through ours and left its memory behind. Astronomers have traced some of these stellar streams using precise measurements from the Gaia satellite. They form long, delicate arcs across the sky, the remnants of ancient galaxies that were pulled apart and absorbed. And these interactions didn't just decorate the Milky Way. They reshaped it. Every collision added mass, stirred the disk, and left ripples in its wake. Our galaxy, it turns out, is not a monument. It's a survivor. Even our galaxy's central bar, that bright, elongated structure of stars at its core, may twist slowly like a turning key, driving gas inward and shaping the spiral arms. Over billions of years, the bar might rotate, subtly altering the balance of the entire disk. It's as though the galaxy's heart beats, and the rhythm carries outward through its spiral arms, bending and flexing the outer regions. This hidden motion, this quiet cosmic elasticity, tells us something profound, ebree, that even things which seem eternal are in motion. Even the structures that last for billions of years are alive with change. And maybe that's what gives the Milky Way its beauty, not perfection, but movement, not symmetry, but story. The next time you look up and see that glowing band across the night sky, imagine that it's not a straight ribbon of stars, but a rippled wave, slowly bending as it drifts through time. Every atom of light that reaches you has traveled through this warped sea, shaped by gravity, by memory, by collisions long past. And in that light is a whisper of resilience, a reminder that even galaxies bend but do not break. They carry the marks of their history, and in doing so, they become more beautiful, more real. So, as you rest, let that image linger in your mind, a galaxy not rigid, but graceful, its edges curved like the breath of a sleeping giant. And perhaps, in that motion, you'll feel something familiar, the way your own story, too, bends and changes, shaped by unseen forces, yet still moving toward balance. If this quiet exploration helps you find peace in the vastness, please leave a like, subscribe, or become a member of Space for Sleep. Your small act of support keeps these cosmic stories slow, thoughtful, and free of interruptions, a place where curiosity can drift without hurry. Now, close your eyes. Picture the galaxy turning, its spiral arms breathing, its edges curling in the dark. You are part of that curve, a spark of awareness riding the ripple of a living galaxy, and it's still moving, softly, endlessly, through time. Every living thing has a center, a heartbeat, a pulse, a quiet place where everything begins and ends. Galaxies are no different. At the heart of our Milky Way, hidden behind curtains of dust and time, there lies something immense and silent. It doesn't shine, it doesn't speak, yet it holds the galaxy together. We call it Sagittarius A, a supermassive black hole, roughly 3 million times the mass of the Sun. It sits about 26,000 light-years away in the direction of the constellation Sagittarius, wrapped in a haze of stars and radio light. For most of human history, we didn't know it was there. We only saw the glow, a dense crowd of stars packed more tightly than anywhere else in the galaxy. It wasn't until the end of the 20th century that astronomers using infrared telescopes began to notice something strange. Stars near the center were moving too fast, whipping around an invisible point at breakneck speeds. One in particular, a bright little star called S2, completes an orbit in just 16 years. At its closest, it races at nearly 5,000 kilometers per second, fast enough to travel from Earth to the Moon in less than a minute. Only something extremely massive and compact could cause that kind of motion. And there, at the focus of their orbits, was nothing. No light, no object we could see, just gravity. That invisible gravity was Sagittarius A, a black hole so dense that even light cannot escape it. It's not a hole in the usual sense, not empty space, but a region where matter has collapsed completely, compressing all its mass into a single point. Around it lies the event horizon, a boundary beyond which nothing returns. It's the ultimate edge, the end of light. If you could drift close enough to see it, you wouldn't see darkness. Not exactly. You'd see a halo of light, the last glow of matter spiraling inward before vanishing. Hot gas, magnetic fields, and starlight swirl together, releasing bursts of X-rays and radio waves. It's a silent storm, blazing invisibly to human eyes but brilliant in radio and infrared. In 2019, the Event Horizon Telescope gave us the first direct image of such a black hole, not of Sagittarius A itself, but of one in the distant galaxy M87. Then, in 2022, it turned its gaze homeward. The image we received wasn't a single photograph, but a composite of data from telescopes all around the Earth, stitched together by algorithms and patience. And there it was, a soft, glowing ring of light surrounding a dark center. The shadow of Sagittarius A. A picture not of what it is, but of what it does. Bending light, curving space, marking the center of our galaxy's heartbeat. It's humbling, isn't it? That the Milky Way, this grand ocean of stars, spins around something utterly invisible. We orbit emptiness, or rather, we orbit the gravity of something so complete that nothing can escape it. And yet, without it, the galaxy would not hold together. The black hole is not a destroyer, it's an anchor. It shapes the stars, organizes the gas, and gives the Milky Way its center of balance. Around Sagittarius A, the region known as the Central Molecular Zone, is a storm of creation. Here, clouds of gas stretch for hundreds of light-years, dense enough to form thousands of new stars. Supernovae light up the region like cosmic fireworks. Massive clusters drift in and out, feeding the black hole occasionally with streams of gas. Sometimes it flares. A sudden, brief brightening as a bit of material falls inward and releases its last burst of energy. Then, once again, it sleeps. If you could float there, safely, impossibly, you'd see stars darting like fireflies, their paths curved by invisible gravity. You'd feel time itself begin to slow. Near a black hole, time bends just like light. Minutes could stretch into years, hours into centuries. The closer you get, the slower everything becomes, until at the edge, time stops completely. To fall in is to fall forever, in every sense. And yet, from this strange silence, our galaxy finds its rhythm. Just as the heart's stillness between beats keeps the body alive, the black hole's quiet gravity holds the Milky Way in place. Around it, stars orbit around them, planets spin. Around those we move and wonder. It's curious to think that everything we know, every atom, every dream, every voice, is part of a system whose center cannot be seen. It reminds us that not all power is visible, and not all light comes from shining. Sometimes it's the unseen pull, the quiet center, that gives shape to everything else. If you've ever felt small or unseen, remember this: even the galaxy's heart is invisible, and yet it holds the stars together. So take a slow breath. Imagine the center of the Milky Way, a silent gravity well glowing with the memory of light. That's where everything you know is anchored. A still point in an ever-turning universe. If this calm journey into the galaxy's heart brings you peace, please leave a like, subscribe, or become a member of Space for Sleep. Your quiet support lets me keep making these ad-free nights of science and stillness. Now, close your eyes. Picture the black hole, not as an end, but as a beginning. A place where time rests and light bends softly back toward creation. Let the thought settle like gravity. You are orbiting it, right now. You are part of the heartbeat of a galaxy. If the heart of the Milky Way is a storm of gravity, the place we live is its calm outer breeze. Out here, about 26,000 light-years from the galactic center, the stars are fewer, the space between them wider, and the rhythms gentler. This is our corner of the galaxy, our stellar neighborhood, our cosmic suburb. It doesn't look like much, but to us, it's everything. The sun is an ordinary star, a quiet yellow-white sphere burning hydrogen into helium, neither too large nor too small. Yet in its ordinariness lies a kind of grace. It belongs to a class called G-type main sequence stars. Stable, long-lived and steady, it has been shining for 6 billion years, and it will likely shine for 5 billion more before swelling into a red giant and leaving behind a white-hot ember. For now, it rests halfway through its life, breathing evenly in the dark. Our sun travels through space with a small entourage. The solar system, 8 planets, dozens of moons, countless asteroids, and trillions of icy fragments drifting far beyond Pluto. Together, they orbit the galaxy like a single grain of dust, riding a great invisible current. Every 230 million years, the sun completes one lap around the Milky Way. That means, since life began on Earth, our world has circled the galaxy more than 15 times, life evolving beneath changing constellations, while our star quietly followed its endless path. But the sun is not alone. In a sphere about 17 light-years wide around us, there are roughly 50 stars, some brighter, some dimmer, most of them cooler than our own. This region is called the local bubble, a cavity of hot, thin gas likely carved by ancient supernovae millions of years ago. Imagine living inside a great cosmic hollow, a soft shell of space shaped by the explosions of stars long gone. That's where we are now, floating in their aftermath, warmed by their memory. Our nearest stellar neighbor is Proxima Centauri, a faint red dwarf about 24 light-years away. It's small, barely 1/10 the mass of the sun, and it flickers with powerful flares that would strip the atmosphere from any nearby planet. And yet, it does have planets. One of them, Proxima b, sits in the star's habitable zone, where liquid water could exist, at least in theory. We may never stand there, but just knowing it exists reminds us that the story of life could be told more than once across the galaxy. Scattered around us are other bright companions, Alpha Centauri A and B, a pair of sun-like stars locked in an elegant orbit, Barnard's star, a restless red dwarf rushing through space faster than most, Sirius, the brightest star in our night sky, only 8.5 light-years away, dazzling white and double-hearted, with a faint white dwarf companion beside it. If you could step outside the solar system and look around in every direction, you'd see a delicate pattern, small clusters of stars, threads of light tracing invisible currents through space. You'd see our sun as one among billions, indistinguishable from the rest. And yet, from this ordinary star came warmth, chemistry, and consciousness. From this faint point of light came you. Astronomers often call this region the Orion Arm, or sometimes the Orion Spur, a smaller branch between two major spiral arms of the galaxy. We lie between the Sagittarius Arm and the Perseus Arm, nestled in a minor lane of stars and dust about 3,500 light-years wide. It's not a grand avenue, more like a quiet side street in a sprawling cosmic city. And maybe that's why it feels so peaceful here, not too crowded, not too empty. A perfect place for life to unfold. From Earth, we see this neighborhood as constellations: Orion, Cygnus, Lyra, Cassiopeia. Patterns humans have traced for tens of thousands of years, but in truth, those shapes are illusions of perspective. Each star sits at a different distance, scattered through the spiral arm. The hunter, the swan, the harp. They're temporary alignments, like candles floating in different parts of a vast cathedral. Over millions of years, they drift apart, reshaping the sky. Even the constellations are only stories told across motion. Within this neighborhood, stars are born and die in quiet cycles. In dark clouds of gas, new suns ignite. In brilliant explosions, old ones fade. Each supernova enriches the space around it with heavier elements: carbon, oxygen, iron, the building blocks of worlds and life. Our own bodies carry the atoms forged in those ancient deaths. When you breathe, you're breathing the recycled dust of generations of stars. The calcium in your bones was once the heart of a red giant. The iron in your blood once glowed at the core of a supernova. We are the Milky Way, thinking about itself. Sometimes, astronomers describe our stellar neighborhood as a galactic garden. Stars blooming, fading, and blooming again. Each one is a sun somewhere, with its own planets, its own stories, perhaps even its own forms of wonder. And all of them drift together, orbiting the galactic center like pollen in a vast luminous wind. If you step outside tonight, and the sky is clear, look up toward the faint glow of the Milky Way. Know that you're seeing your neighborhood from the inside, countless suns glowing through the haze of distance. Each one a light that took years, centuries, sometimes millennia to reach you. Every star is a time capsule. Every glimmer is a message from the past. So take a deep breath. Let that light rest gently on your mind. You're not just looking at the galaxy, you're living inside it. Every cell of you is made of its dust. Every thought you've ever had is powered by a star. And though we are small, we are also cosmic, fragments of the Milky Way remembering their origin. If this quiet exploration helps you feel at home in the universe, please leave a like, subscribe, or become a member of Space for Sleep. Your support keeps these journeys slow, soothing, and ad-free, a soft place where science meets stillness. Now, close your eyes for a moment. Picture the stars drifting around you, faint companions in an endless night. You are not lost in the galaxy. You are home among the stars. Every story has an edge. Even something as vast as a galaxy must end somewhere, though not in a line or a wall, but in a slow, beautiful fading. The Milky Way does not stop, it simply thins. The further you go from its center, the more the stars drift apart, until eventually their light becomes so sparse that the darkness takes over. That is where the galaxy ends, not with a border, but with a whisper. From the bright core to the spiral arms, from our sun's neighborhood to the outer rim, the Milky Way stretches across nearly 100,000 light-years. That number is hard to hold in the mind. It means that if you traveled at the speed of light, 300,000 kilometers per second, it would still take you 100,000 years just to cross from one side to the other. And yet, even that distance is only the visible part. the bright, starry disk we can see in telescopes. Beyond that disk lies something fainter, softer, almost ghostly, the galactic halo. It's not made of light, but of memory, a vast spherical cloud of ancient stars, star clusters and dark matter, extending perhaps 300,000 light-years in every direction. Out here, the stars are old, billions of years old, fossils from the early days of the Milky Way's formation. Many belong to the globular clusters, tight, glittering balls of hundreds of thousands of stars, orbiting far above and below the galactic plane. Each cluster is like a miniature galaxy, preserved from a time when the universe was young and full of chaos. If you could float out there, in the galactic halo, the Milky Way would hang before you like a glowing spiral. Delicate, immense, turning slowly in the dark. You would see its bright arms, its glowing core, and the faint wisps of gas that trail beyond it. And then, beyond that, almost imperceptibly, the light would fade into the infinite black, the quiet sea between galaxies. But even in that dark, the galaxy doesn't truly end. Its dark matter halo extends much farther still, an invisible sphere of gravity, perhaps 1,000,000 light-years wide. We can't see it, but we can feel its pull. It's the unseen structure that keeps the Milky Way together, binding stars and gas and dust in a cosmic cocoon. Without it, the outer stars would fly away into space, and our spiral would unravel like smoke in the wind. Astronomers know the dark matter halo is there because of how the galaxy spins. The stars at the edges move faster than they should, as if something unseen is holding them close. That something is dark matter, a vast, mysterious presence that makes up most of the galaxy's mass, yet emits no light. It's both nothing and everything, the silent framework upon which the Milky Way is built. At the visible edge of the disk, the stars become so few that space feels almost empty. But this outer region isn't lifeless. It's dynamic, full of movement and subtle structure. There are faint streams of stars, torn from smaller galaxies that once collided with ours. Some are remnants of ancient mergers, ghostly trails curving around the galaxy, like the afterimages of forgotten dances. The Sagittarius stream, for example, wraps around the Milky Way like a ribbon of scattered starlight. The remains of the Sagittarius dwarf galaxy, slowly being absorbed into our own. And beyond even those faint streams, there lies an invisible boundary, the galactic corona, a hot, diffuse halo of gas that extends far beyond the last visible stars. It's so thin that if you scooped up a cubic kilometer of it, you might find only a handful of atoms. Yet across millions of light-years, that gas glows faintly in X-rays, marking the true reach of our galaxy's influence. So where does the Milky Way end? The answer depends on what you mean by end. For the stars, it ends around 100,000 light-years from the center. For the gas, maybe 200,000. For the dark matter, perhaps 1,000,000. But in truth, galaxies are not like islands. They blend, they merge, they reach out and touch each other across the cosmic ocean. Our Milky Way's outermost halo already mingles with that of the Andromeda galaxy too, 5 million light-years away. In a sense, the two galaxies are already connected, their edges intertwined in the dark. And one day, billions of years from now, they will meet. The Milky Way and Andromeda are moving toward each other at about 110 kilometers per second. In roughly 4 billion years, they will collide, their stars passing through one another like ghosts, their shapes merging into a new, larger galaxy, sometimes called Milkdromeda. It will be a grand, slow ballet, not a crash, but a blending. No stars will collide, but gravity will reshape everything. Our galaxy's edges will become its heart, its spiral arms will dissolve, and a new, elliptical galaxy will emerge from the ruins. So when we speak of edges, we are speaking only of moments, of temporary boundaries in a universe that never truly stops. Even the outermost border of the Milky Way is just a pause before another beginning. If you were to drift there now, beyond the last shining stars, you would find silence, not emptiness exactly, but stillness, the soft hum of background radiation, the occasional glimmer of a distant quasar. And behind you, far away, the faint spiral glow of your home, the Milky Way, a single swirl of light in the endless dark. Take a breath and imagine that view. The galaxy small and shining behind you, the void stretching ahead. You are at the edge of everything you've ever known. And yet somehow you belong here too, because even out there, you're still held by its gravity. You're still part of its story. If this journey to the galaxy's edge brought you calm or wonder, please leave a like, subscribe, or become a member of Space for Sleep. Your support keeps these cosmic explorations slow, peaceful, and ad-free, made for minds that love to drift through the vastness and find rest there. Now, close your eyes, let the image settle. The Milky Way, soft and luminous, floating alone in the dark. You are looking back at your home from the frontier of the universe. And even here, in the quiet beyond light, you are still part of it. Nothing in the universe is truly still. Not the stars, not the planets, not even the vast galaxy we call home. Everything moves, gliding through space on invisible currents of gravity, like leaves floating in a cosmic river. The Milky Way may look calm from afar, a quiet spiral, suspended in the dark, but it's anything but motionless. It spins, it drifts, it ripples, and it dances through the universe with astonishing speed and grace. Right now, as you listen, our entire galaxy, the hundreds of billions of stars, the black hole at its center, the glowing arms and dark matter halo, is moving at nearly 1 million kilometers per hour through space. And yet, we don't feel a thing. Let's start small. Our sun orbits the center of the Milky Way, pulled along by gravity. It travels at about 220 kilometers per second, roughly 500,000 miles per hour, around the galactic center. At that speed, it takes about 230 million years to complete one orbit. That means since the sun was born, it has gone around the Milky Way only about 20 times, just 20 galactic years in 5 billion Earth years. Every star you see in the night sky is doing the same, each tracing its own orbit around the galactic core, each moving in its own curve of space and time. Some go faster, some slower, some on tilted orbits that rise above or dip below the galactic plane. Together, they form the grand rotation, the heartbeat of the Milky Way's motion. If you could watch the galaxy from far above, you'd see its arms turning like the slow swirl of cream in dark coffee. But here's a secret: those spiral arms aren't solid structures. They're waves, patterns of density moving through the disk. Stars move in and out of them, just as cars flow in and out of a traffic jam. The spiral pattern itself turns more slowly than the stars within it. So what you see, those bright, graceful arms, are not fixed. They're constantly forming, fading, and reforming. The Milky Way is not a rigid wheel, it's a living ripple, a fluid pattern of stars and gas. Now, step back. Because even as the Milky Way spins, the entire galaxy is also moving, gliding through the local group, our small cosmic neighborhood of about 80 galaxies. The Milky Way and Andromeda are the two largest members of this group, each surrounded by smaller companions like the Large and Small Magellanic Clouds, the Sagittarius Dwarf Galaxy, and dozens of faint satellites. Together, they orbit a common center of mass, drawn by gravity toward one another. Right now, the Milky Way is rushing toward Andromeda at about 110 kilometers per second. Each second, the distance between them shrinks. It sounds dramatic, two giant galaxies on a collision course, but in cosmic terms, it's a slow and graceful drift. The collision won't happen for another 4 billion years. And when it does, the galaxies will pass through one another almost like ghosts. Their stars are so far apart that direct collisions will be rare. Instead, their shapes will warp and twist under gravity, flinging long tails of stars into space. Eventually, they'll merge into one vast elliptical galaxy, calm, golden, and immense. Perhaps new stars will be born in the chaos, and new worlds will find their place among the ruins. It will be an ending, but also a beginning. But the story of motion doesn't stop there, because the local group itself, all those galaxies, including ours, is being carried along through an even greater flow of space. We are moving toward a region called the Virgo cluster, a massive collection of thousands of galaxies. And beyond even that, everything in our local universe seems to be streaming towards something larger still, a mysterious gravitational anomaly known as the Great Attractor. It lies hundreds of millions of light years away, hidden behind the dense dust of our own galaxy. We can't see it directly, but we can feel its pull. The entire Milky Way, the entire local group, is drifting toward it at nearly 600 kilometers per second. So think about that for a moment. You, right now, sitting quietly, maybe beneath a blanket, are moving through space over 2 million kilometers per hour. The Earth spins beneath you. The planet orbits the Sun orbits the Milky Way, and the Milky Way itself surfs the waves of cosmic gravity. And through it all, this endless, layered motion, you feel perfectly still. That's because motion in space is relative. You can only feel movement when you have something to move against. But in the vastness of space, everything moves together. There is no absolute stillness, and somehow there's peace in that. You don't need to stand still to find calm. You can be part of something endlessly in motion and still feel centered. The Milky Way proves that, a spinning, drifting, pulsing galaxy that never stops moving and yet remains whole. If you were to step outside tonight and look up, the stars you see, those quiet points of light, are part of that motion. Each one is flying through space, circling the galaxy, riding invisible tides of gravity. And yet, from here, they seem eternal, still, peaceful. The universe moves, but it never hurries. It flows, it drifts, it takes its time. And maybe, in our own way, we can learn from that, to move without rushing, to change without fear, to trust that, even when everything is in motion, we are still part of something beautifully balanced. If this quiet journey through the motion of the Milky Way brought you calm, please leave a like, subscribe, or become a member of Space for Sleep. It helps keep these cosmic stories slow, ad-free, and crafted with care, made for dreamers who love to rest among the stars. Now, take a deep breath. Imagine the galaxy around you, turning softly, carrying you along. You are moving at millions of kilometers per hour, and yet you are perfectly still, floating, at peace. When we look at the night sky, we see a galaxy of light, billions of stars scattered like glitter across the darkness. But what we see is only a fraction of what is. Most of the Milky Way, most of any galaxy, in fact, is hidden, invisible to our eyes, a structure built not of light, but of gravity, magnetism, and something we still barely understand. If the galaxy were a living being, then its bright disk, the stars, the nebulae, the glowing arms, would be its skin. But beneath that skin lies a skeleton, vast, invisible, holding everything in place. We call that skeleton dark matter. It's one of the greatest mysteries in modern science. We can't see it, touch it, or detect it directly. And yet, we know it's there. We can feel it through its gravity, a pull so massive that it shapes the motions of stars, galaxies, and clusters across the entire universe. In the Milky Way, dark matter forms an enormous halo, stretching far beyond the visible disk, perhaps 1 million light-years across. It's like an invisible cloud wrapping around the galaxy, surrounding every star and planet you know. If the Milky Way were the size of a coin, that halo would extend for miles in every direction. It doesn't glow, it doesn't scatter light, but without it, the galaxy would simply fly apart. Astronomers first discovered dark matter's influence by studying the way stars move. They expected the outer stars of the galaxy to move slower than the inner ones, just as the outer planets of our solar system orbit more slowly than those close to the Sun. But that's not what they found. The stars at the edges of the Milky Way were moving just as fast as those near the center. Something unseen was holding them in. That something was dark matter. Today, we believe that nearly 85% of the galaxy's mass is dark matter, unseen, silent, but crucial. Without it, there would be no spiral arms, no stable disk, no long-lived galaxy at all. It is the quiet architecture of the cosmos, the invisible stage upon which the stars perform. But dark matter isn't the only hidden structure shaping our galaxy. Threaded through the Milky Way is another invisible force: magnetism. A vast galactic magnetic field runs through space like veins through a living body. It's faint, 1,000,000,000 times weaker than a refrigerator magnet, yet powerful enough to guide the motion of cosmic dust, charged particles, and even star formation. These magnetic fields twist and spiral along with the galaxy's rotation. They shape the flow of gas, help sculpt the arms, and sometimes trap high-energy particles in glowing filaments. In radio waves, we can trace their presence: long, luminous tendrils weaving through the galactic plane, stretching for thousands of light-years. They shimmer unseen in the visible spectrum, but their influence is everywhere. If you could see the Milky Way's hidden skeleton, its dark matter halo and magnetic filaments, you'd be astonished. The galaxy would no longer look like a flat spiral. It would be surrounded by a web, a glowing mesh of invisible lines, like silk stretched through the void. The stars would shine at the intersections, like beads caught in an unseen net. And if you zoomed out farther still, you'd find that this web doesn't stop with our galaxy. It extends across the entire universe. Every galaxy, ours included, is a node in this cosmic web. Long filaments of dark matter connect them like arteries between organs. Where those filaments cross, galaxies form. Between them lie vast voids, regions of almost perfect emptiness. This structure, first glimpsed in simulations and later mapped by surveys like Sloan and Planck, shows us that the universe itself is not random. It's organized, structured, alive with geometry. The Milky Way is part of that vast web, not floating alone, but anchored by invisible threads to everything else. Every motion of a star, every flicker of light, every planet orbiting in silence, all of it exists within this hidden framework. It's easy to think of the galaxy as isolated, a single island of stars. But in truth, it's one piece of a much larger pattern, one ripple in the endless sea of cosmic structure. And perhaps there's a quiet comfort in that. Even when we can't see the connections, they're there. Gravity binding us, magnetism weaving through us, dark matter holding us steady. The visible world is only the surface of a deeper harmony. Take a moment to breathe that in. You are not floating alone in emptiness. You are suspended in a web of invisible forces, ancient, vast, and patient. The same hidden structure that shapes galaxies also shapes you. Atoms, fields, and gravity, all part of one great, unseen design. If this peaceful journey into the hidden structure of our galaxy brought you a moment of awe, please leave a like, subscribe, or become a member of Space for Sleep. It helps keep these explorations slow, thoughtful, and ad-free, a place where science and stillness can coexist. Now, close your eyes. Imagine the Milky Way not as a picture of light, but as a vast glowing web of gravity and magnetism. Luminous where stars form, dark where silence holds. That's your home. That's what you're part of, the invisible skeleton of a living galaxy. How big is our Milky Way galaxy? It's a question that sounds simple, a measurement, a number, a line drawn in light years. But as with all great cosmic questions, the answer expands the moment you try to hold it. Let's start with what we can measure. From end to end, the Milky Way's bright star-filled disk stretches about 100,000 light-years across. Its central bulge, the dense, glowing heart, spans about 10,000 light-years. And its thin spiral arms, home to gas, dust, and most of the galaxy's stars, measure roughly 1,000 light-years thick. If you could travel at the speed of light, it would take you a full 100,000 years just to cross the visible galaxy from one side to the other. But that's only part of the story. The Milky Way's invisible dark matter halo extends far beyond that, perhaps as much as 1,000,000 light-years in diameter. That means the true galaxy is 10 times larger than what we can see. Most of its mass lies in darkness, not in light. So when we ask how big it is, we must remember the Milky Way's borders aren't drawn in stars, but in gravity. Inside that enormous halo live hundreds of billions of stars, somewhere between 100 and 400 billion, depending on how you count. Surrounding them are trillions of planets, perhaps one for every star, and more worlds than there are grains of sand on all of Earth's beaches. Between the stars drift clouds of dust and gas, glowing faintly where new suns are born, and threaded through it all are magnetic fields, filaments of plasma, and the ghostly scaffolding of dark matter. It's hard to imagine something that large, so instead, let's shrink it down. If the Milky Way were the size of North America, our entire solar system would be smaller than a coffee cup sitting in a quiet park somewhere. Every human story, every sunrise, every sound you've ever heard, all of it happening inside that tiny cup, drifting through the vastness of the continent. Now imagine that continent floating through space, surrounded by hundreds of others, each one a galaxy, each one home to its own suns and worlds and possibilities. That's the scale of the universe we live in. And yet, even that isn't the whole truth, because the Milky Way itself is just one member of the local group, a family of galaxies bound together by gravity. That local group belongs to an even larger structure, the Virgo supercluster, which itself is just one filament in the Laniakea supercluster, a structure spanning 500 million light-years, and beyond that, more clusters of clusters stretching outward into infinity. The farther we look, the more the universe reveals its boundlessness. So perhaps the question isn't just how big is the Milky Way? Brie. Perhaps it's how big are we willing to imagine? Because in one sense, galaxy is vast beyond comprehension. A rotating island of stars 100,000 light-years wide, home to billions of suns. But in another sense, it's small, a single spiral in an endless cosmic ocean. And from yet another view, it's intimate, because everything you are, every atom in your body, was born from its stars. You are part of its size, its history, its matter. You're not outside of it, looking in. You are the Milky Way, given consciousness. The galaxy's true size isn't measured in light-years or mass, but in connection. It's as big as every orbit, every photon, every dream that reaches into the night sky. It's as big as the awe it inspires, as the silence it brings when you look up and realize you are standing on a tiny world, inside a spiral of light, moving through eternity. Take a moment to imagine that. You're floating halfway out on one of the spiral arms, inside a thin band of starlight. Above you, billions of suns form a river of white and gold, curving around a glowing center. Below you, the darkness of the galactic halo stretches into infinity. And somewhere out there, another being, on another world, might be looking up and wondering the same thing. Hebrews, how big is it all? Hebrew. Maybe the answer isn't meant to fit in numbers. Maybe it's meant to quiet us, to remind us that size isn't about boundaries, but belonging. We are inside something so vast it cannot be held, and yet it holds us completely. The Milky Way is not just where we live, it's what we are made of. Every carbon atom in your body, every oxygen molecule you breathe, every calcium particle in your bones, all of it was forged in the hearts of ancient stars that lived and died long before the Earth was born. Their light became you, their dust became home. So the next time you step outside on a clear night, look up. That faint milky band arcing across the sky. That's not just the galaxy you're in, that's the galaxy you are. It's your origin story written in light. How big is the Milky Way? It's 100,000 light-years wide. It's 1,000,000 light-years across if you count its invisible halo. It's home to billions of stars and trillions of worlds. But most of all, it's big enough to hold everything we've ever known, everything we've ever dreamed, and everything we've ever been. If this long, peaceful journey through our galactic home brought you wonder or calm, please leave a like, subscribe, or become a member of Space for Sleep. Your gentle support keeps these cosmic explorations ad-free, unhurried, and full of starlight. It helps me craft more of these slow, meditative stories for minds that love both science and serenity. Now, close your eyes. Take a slow breath. Feel the motion of the galaxy carrying you through space, softly, endlessly. You are not small, you are part of something immeasurable. And tonight, as you drift into sleep beneath the Milky Way's glow, remember this: Ibrahim, you are home.